Hey guys, welcome to this session by Intellipath. Now you guys must have come across the term Python programming and numerous questions would have popped into your head. So is it just another programming language? How is it different from other programming languages? And is it really hard to learn Python programming? So today we've come up with just the right video so that you can start your journey in the field of Python programming. So let's have a quick glance at the agenda. We'll start off by understanding what exactly is Python, and then we'll work with different data types in Python. Following which, we'll learn how to work with flow control statements and learn how to create user-defined functions. Going ahead, we'll learn how to implement mathematical operations on multi-dimensional arrays using NumPy. And then we'll do data manipulation with the pandas library and data visualization with the matplotlib library. And finally, we'll learn how to handle real-time big data using PySpark.
So what is Python? Well, Python is a high-level object-oriented programming language for general-purpose programming. It is one of the most widely used high-level programming language and is well known for executing basic tasks with less code, which makes it more compact and an economical language to learn. If you see, Python code is often 3 to 5 times shorter than the Java codes, and around 5 to 10 times shorter than C++ codes. Well, if you talk about its history, it was developed by Guido van Rossum in the year 1991, and since then its open source community is still growing. So how do you think he came up with this name? Was it because of a snake? Well, no. Rossum named Python over the name of a sitcom TV series, Monty's Python Flying Circus. It seems he was highly impressed with the show, right? So these were some of the high-level introduction to Python. Now, a question might arise in your mind that what made Python so popular or why you should learn it. So let's discuss it one by one. So the first point we have is simple and easy to learn. Well, if you compare Python with any other language, for example Java or C++, you'll find that its syntax is way lot easier than them. You don't have to worry about the missing semicolons in the end. And its syntax is more readable and you are safe from writing multiple lines of code just for printing a statement, like in case of Java. If you talk about Python, all you need to write is just one line of statement. For example, print, and within the double quotes, mention whatever you want to print. So this is how it is simple and easy to learn. The next point comes the career opportunity. Well, like I told you in the beginning of this video itself that Python has a huge career opportunity in the IT industry. Almost every other IT company, be it a startup or a multi-billionaire company, are using Python in some or the other ways. So if you're a Python developer, you will be in a huge demand for a wide range of jobs in the domain of machine learning, databases, data analysis, cloud infrastructure, website designing, website reliability, testing, scraping, security, mobile developments, and many more. If you don't trust my words, just go and look out for Python developer job on any major job website. You will find thousands of job opportunities out there with an average salary of around $116,000. This indicates that there are many companies out there who are competing to hire a knowledgeable Python developer for them. So yeah, you have a huge career opportunity in Python. It all depends on your skill. Alright. Next is large open source community. Well, if you become a Python developer and when you are stuck or you want to learn something new, then you don't have to worry about it. You'll find a large number of resources like reference manuals, books, tutorials, videos, forums, etc. out there on the internet. If you have any doubt or some technical issues, you can directly seek help from thousands of Python community members on forums, Twitter, Facebook, and pretty much everywhere. Now, since Python is an open source community, you will always find people who are trying to improve it, keeping it fresh and up to date with current trends and bringing out newer version of the language. Right? So yeah, it has a damn large open source community. Next we have is reliable and efficient. Ask any Python developer or anyone who has ever used the language and they will agree that it's speedy, reliable and more efficient. You can work with and deploy Python applications in nearly any environment and there's little to no performance loss no matter what platform you work with. Again, because it's versatile, this also means that you can work across several domains including web development, desktop application, mobile applications, and many more. You're not bound to a single platform or domain as it offers the same experience almost everywhere. Alright, so next we have is the extensive library. Well, Python has a huge set of library list which would be useful for any programmer interested in Python depending on their area of interest. For example, you have NumPy for scientific computing, Plotlib for data visualization, NLTK for natural language processing, Django for web framework, Pygame for game development, and there are many more. It can be used in a lot of places and has a wide variety of application. Like for web development, you can use Python web framework like Django, Flask, and Tornado. If you are into developing desktop application, you can go with PyGTK and Cocoa. If you are planning to use Python in the field of machine learning or deep learning or data science, you'll find many Python libraries for it, like sklearn, TensorFlow, Theano, NLTK, and many more. If you talk about cloud and DevOps, you can use OpenStack Python Software Development Kit, which is generally used to write Python automation scripts to create and manage resources in your OpenStack cloud. You can even use a Python library named Fabric for streamlining the use of SSH for application development or system administration tasks. Alright, last what we have is hardware programming. Next, if you're planning to switch over to hardware programming, you have Raspberry Pi to connect your project to the real world with Python. Well, now that you know how important is Python to the world, let's see the popularity of Python in industry. Well, big tech giants are using Python. In fact, Python is one of the Google's favorite languages. They are always hiring experts in it and they have even created many of their popular products with it. Well, I don't think I should again mention that since many big companies like Yahoo, Facebook, Netflix, Dropbox, YouTube, BitTorrent, NASA, and many other rely on Python developers. So these companies are always in search of talented professionals who have already worked on and have some experience in Python. There is and there always be a demand for Python developers and Python web developers, and they are even offered some decent packages. Well, this was all about the background check of Python. Now let's move ahead and dive deep into Python programming. So the very first thing that we'll be doing is installing Python on our system. So I have already installed Python in my system. For those of you who don't have it, you can download it and get it installed from its official website www.python.org/download. So let me just show you how easy is it to install Python on your system. Let me open my default browser and I'll write here www.python.org/download. So as you can see here, we have a download option of download Python 3.7.1. If you want a different version for Windows, Linux or Mac, you can just click over to these links. For example, if I am a Windows user and I want a different version of it, then let's see. I click the link and you can download different versions of Python from here. So the first two options that we got up here is latest Python 3 release, Python 3.7.1 and latest Python 2 release, Python 2.7.15. Now these are the two popular versions of Python. Now which version should you download? Well, I have installed Python 3 in my machine. In the past, there was a bit of debate in the coding community about which Python version was the best one to learn, Python 2 or Python 3. Specifically Python 2.7 or Python 3.5 or 3.7. Alright, let me just tell you, Python 2 has been most popular version for a decade and a half and is still in demand at certain companies. However, more companies are moving from Python 2 to Python 3. For example, in 2017, Instagram migrated the majority of their Python codebase from Python 2.7 to Python 3. As with each newer version of Python, it is getting a faster runtime. On the other hand, nobody is currently working on to make Python 2.7 work faster. Also, the community support for Python 3 is more better. So for someone who wants to learn Python programming for beginner, I'd suggest that you should avoid spending time on a version that is becoming obsolete. Well, let's download Python 3 for Windows. So let's directly jump up to our first window and click on download Python 3.7.1. Download it. So yeah, it's downloaded. Just click over the .exe file and follow the installation step and it will get installed. Click it Click on the install now version, select the drive where you want to install it and click on the next and it will be installed on your machine. Alright, so let's click on the install now option. Yes. And the setup will install Python on my system. Well, if you are starting Python, you will find that you will have various options where you can write down your codes and get it executed. By default, we use the Python CLI. You can use any text editor like Notepad or Notepad++, or you can even use any Python IDE like Anaconda, which has Jupyter Notebook and Spider pre-installed in it. Python is majorly based on indentation, so these IDEs will help you a lot while coding and debugging your program. So by then my setup was successful. Let's close it. For this tutorial, I'll be using Jupyter Notebook, which is a web-based application that will allow me to write my Python codes on it. It's very to use and it gives me an interactive data science environment. Alright, if you're installing Jupyter Notebook and Python, I would strongly recommend you to use the Anaconda distribution, which already includes the Python, the Jupyter Notebook and other commonly used packages for starting with Python. Alright, so for downloading it, let's visit the website www.anaconda.com/download. Let's open our default browser, www.anaconda.com/downloads. So as you can see, we have a download option up here. Just click over it and your installation will start. Open the downloaded file and follow this series of steps and install Anaconda on your machine. Alright. So for me, I have already installed Anaconda on my system. So let me just go over there and open it. Anaconda Navigator. This might take some time to start. So this is how the Anaconda Navigator looks like after the installation. From here, I'll select my Jupyter Notebook and hit the launch button. My Jupyter Notebook will open in my default browser. So here's my Jupyter Notebook. It opened on the local host with port number 8889. So this is how the Jupyter Notebook will look like. So from here, go on to the new, select Python 3 from the notebook. And this will redirect you to the Python notebook page where you can write all the different sorts of Python codes on it, ranging from a beginner level to advanced one. Now that we have set up our environment for coding, let me just give you a glimpse of how easy is Python. You want to perform addition? It's as simple as 1 plus 2 equals 3. That's it. All you need to do is 1 plus 2 and hit enter. You'll get the output. So let's move ahead and let me teach you more about it. So let's get back to our tutorial and see what's our next topic. So our first topic is Python variable. How do you think the values assigned? Well, for assigning the values, there are two different methods. First is assigning single value to a variable, and the next is assigning multiple values to a variable. So let's start with assigning single value to a variable. You know what? Unlike Java or C++, you don't have to add any data type for a variable. Just specify the name of the variable, for example, a equal 10. So depending on your data, Python will automatically detect the data type of your variable, which in this case is integer. Alright, let's see other example. Suppose we have a name as Victor. So Python will automatically detect that this name variable is of data type string, since it stored the string value. Alright, next we have salary as 2000.23. So since 2000.23 is nothing but a floating type, so automatically Python will detect that salary is of a data type float. You don't have to specify a data type to a variable. Alright, let me just show you this example in our Jupyter Notebook. For example, I need to store an integer value. So I'll name a variable like a equal 10. 10 is integer and I'm not specifying any data type for it, right? Hit enter. Since no error is appearing, so I guess it's correct. But what if I just write int a equal 10? So as you can see, it gave me an invalid syntax. So you cannot use any data type before a variable. Alright. Next, what if I want to store a string variable? just like name equal John. Alright, hit enter. Similarly, for a floating data type, salary or any variable name equal 2023.234. Alright, it's as simple as that. Alright. So now that you have learned how you can assign a value to a variable, let's see how you can have multiple assignment to a same variable. Alright. So let's suppose you are assigning three variables as a equal 10, b equal 10, and again c equals 10. So here we have three variables, and what you have to do, you have to assign the same value to all of them. So instead of assigning value one by one, what you can just write? You can just write a equal b equal c equal 10. Alright. And it will be executed without any error. Fine. Now this was simple. Now what if you have to assign different value to each variable? For example, I have a variable as x equal 20, y equal 30, and z equal 40. So in this case, what you can do for multiple assignment, you can just write x comma y comma z equal 20 comma 30 comma 40. It's as simple as that. Now let me just print any of the two variables and check if we are correct or not. So let's print y and let's print a. So yeah. So we got the output as 30 and 10. Y equal 30 and a equal 10. Even if you want, you can just check it by updating the value, like a equal b equal c equal 20. And this is, make it something else, like 40 and 50. And now print the value of y and a. So you'll get the value as 40 and 20. Alright. So this was about the assigning single value to a variable. We also learned about assigning multiple values to a variable. A equal b equal c equal 10, and this example we already did, right? And we got the output as 2010. Fine. So now that you know how you can assign value to a variable, so let's move ahead and start our discussion with some basics of Python. So I'll start with Python token. So what exactly is this Python token? Well, Python token is the smallest meaningful component, or it is a very basic component of the source code. The characters are categorized as one of the four classes of tokens that describe their functions. It can be a keyword, it can be a literal, it can be an identifier, or it can be an operator. Fine. So let's discuss them one by one, starting with keyword. So what are these keywords? Well, these keywords are some sort of reserve words which are designed for a specific purpose. You cannot use a keyword as a variable name or an identifier name. Some of the keywords in Python include for, if, del, break, continue, true, false, etc. You cannot use them as your variable. These words in Python have a specific purpose and have a specific meaning to it. Alright, let's move ahead. Next is the identifier. Well, it is the name which you give to your variable or to your function or to your class. For example, if you are defining a variable as a equal 10, then the word a or the variable a is defining the identifier. Alright. Well, before you start naming your variables or methods or class, you must know that there are certain set of rules or guidelines for naming an identifier. Let's see them one by one. So the first one is no character except the underscore can be used as an identifier. So what does that mean? Let's see. So you cannot have a variable name as 80@123 equal something, any value. You cannot have a variable name like this. It will throw you an error. Alright. Or you cannot even have a variable like 80.we equal 20. Even this will throw you an error. Alright. But instead of it, if you write 80_we, this would be perfectly fine. Alright. Next is keyword should not be used as an identifier name. This I told you earlier also, right? It's like if you are mentioning some keywords like if equal 10, obviously this will throw you an error. Or you're writing while equal 10, when this will give you an error. You cannot use any keyword as a name of an identifier. That is a name of a variable, a class, object, or a function. Alright. Next is Python is case sensitive. That is var with capital V and var with small v are two different identifiers. Let me show you this. Suppose I mention a equal 20 and capital A equal 10. So what do you think the value should be if I print A? Would it be updated to 10 or would it be same as 20? Well, let's see. So the output is 20. So it means that small a or the a in smaller case and a in uppercase both are treated differently in Python. Print capital A. Alright. So let's move ahead. Next and the last one is first character of an identifier can be a character underscore but not a digit. Well, what does this mean? 1 to 80 equal 10. This is wrong. 1 to or 41 at the rate RAC equals something. Even this is wrong. But what you can do instead, you just specify underscore before this. Underscore 41 RAC without the at the rate part, as no special character other than underscore is allowed, equal 10. So this thing will be accepted without any error. Fine. So this was all about the identifiers. Next comes the literals. Well, literals are the constant used in Python. Or you can say that literals are the data given in a variable or a constant. Basically, there are four different types of literals: string literals, numeric literals, boolean literal, and special literal. Let's have a look at them one by one. Starting with string literals. Well, you can create a string literal just by enclosing a text within the code. Both single and double quotes are allowed in a string literal. For example, you can have a variable as name1 equal double quotes John, and you can even have a variable as name2 equal within single quote John, or maybe James. Both are correct. You're not getting any error, right? So since you are not getting any error in the output, so it verifies that you can use both the single and double quotes in string literal. Okay, now what if you have multiple line input? So how will you print that? Let's see for a multiple line input. Multi-line equal. So all you need to do is mention 3 single quotes. Just 3. Alright. And after that, start writing like string 1, enter different line, string 2, line 3, string 3, and so on. Alright. And again, you have to end it using 3 quotes. Fine. Execute it. You won't get any error. And if you print the multi-line, you'll get the output as str1, str2, str3 in 3 different lines. Alright, let's get back to our tutorial. So what was our input? Name1 equal John, name2 equal James, print name1, name2, and we got the output. Yeah, we discussed this. We have a multi-line thing within triple quotes. You had a multi-line thing in which you needed the output in 3 different lines. So yeah, you got it using 3 quotes. Alright, fine. So this was about the string literal. Later in this session, we'll see what are the various other functions you can perform on the string literal using some of the Python's existing library. For now, let's move ahead and let me give you an overview of numeric literal. So what are these numeric literals? A numeric literal is a character string whose characters are selected from the digits 0 to 9. It consists of a sign character. It can be either positive or negative, or it can even contain a decimal point. Well, if the literal contains no decimal point, then it means that it's an integer. If your number is too long and we add capital L or small l at the end of the number, it makes it a long number. Or if the literal contains a decimal point, it becomes a float. But yes, remember that you can only use one decimal point in a number. Have you ever seen a number with more than one decimal point? Never, right? Well, just for the FYI, I'm not talking about the IP. Alright. By the way, in Python, the value of an integer is not restricted by the number of bits. It can expand to the limit of the available memory, and since the value of the integer depends on the available memory, so no special arrangement was made in Python for storing large number. So any doubt up till this portion? Well, if you have, please add it in the comment section below. Alright. So moving on ahead, next we have is the Boolean literal. Well, these Boolean literal have just two values, either true or false. Well, remember that both these true and false are also a keyword. So you cannot use them as an identifier. They are generally used when we are dealing with some condition whose outcome is either true or false. Alright. So this was about the Boolean literal. Next we have is the special literal. Well, Python has just one special literal as none, which is used to specify the field that is not created. Well, if you are from a programming background or you just have a basic knowledge about C, C++ or Java, I think you must have heard about the keyword null, right? Well, if yes, then this null is nothing but the equivalent of null keyword in C, C++ or Java. Alright? So I hope that you guys have understood about literal. Well, there are many cases where you can use none. Let's see an example. It's a self-explanatory example, just go through it and we'll proceed. Alright, nothing needs to be explained in this. So let's move ahead. Okay, I hope that you have understood about literals. So let's move ahead to operators. So what are these operators? Well, these are some specific characters which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes two operands to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand, and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand, and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So, for example, I'm defining a variable var equal 10. So this equal to is nothing but a assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20, since the value of var is already 10. So 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, B equal 20. A is greater than B. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay, let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equal 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1 and again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. That's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Alright. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a NOT of 7, that is NOT of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of NOT of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2, since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right, 00, and remove 10 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0010. Now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010 and you're adding 2 bits in the end, since you are shifting 2 bits to the left. So you are getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 000 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you're getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright. And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pets. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So this was all about the Python token. So moving on ahead, we'll learn about data type in Python. Well, Python has majorly two data types: immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright. Immutable data type consists of numbers, strings and tuples. On the other hand, mutable data type, they consist of lists, dictionaries and sets. Alright. So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has 4 different types of numeric literals: integer, long integer, floating number and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function or complex function. Alright. You have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now what if I want to check the data type of these variables? So how can I do that? So for that we have type function. So print the type of variable A. Alright? Or print the type of variable name. Or print the type of variable salary. Fine. Execute it. Sorry, there's a typo. It's type. Alright. So you can see that variable A is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright. Let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright, let's perform some operations on string and understand them in detail. Suppose I have first string as hello world. And my second string is IntelliPat. Alright. Now what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1 and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello starting from 0 and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 plus 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find, and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5 and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str dot replace. What I want to replace? First mention that I want to replace me with what I want to replace. It's m. Fine. Executed. So you got the output as attachment. attachment. Fine. Me is replaced with m. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach dot replace. So what you need to replace from here is ment. You don't want ment from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the basis of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these 3 different words are separated by comma. So what I want to do, I want to split the entire string on the basis of comma. So I'll write split str dot split on the basis of comma and execute it. So as you can see, I got the output as 3 different words. Word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals IntelliPat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me, it will be 1. I'll tell you why. See, the output is 1 because, remember I told you Python is case sensitive. So both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot u dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me IntelliPat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? Since in capital IntelliPat you have 2 i's. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, @ #123, capital A, small b, small a, c, capital C. Alright. So this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5. Execute it. I must to mention this. Put it under the quotes. Execute it. So the character with maximum ASCII value is small c. Alright. Or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine. So let's move ahead. So next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright. So this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal within the parentheses. I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically, concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. what is the invalid syntax up here? Something is invalid, yeah. Let's define it again. Okay, this semicolon is missing up here. Fine. Executed. So yeah. So this concatenated me and gave me the result as A, B, C, D, E, and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E, and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3, and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple, I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3, and 4. Fine. So I'll get the output as B, C, D, and E. Let's check it. So I got the output as B, C, D, and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learnt in tuple. It is used to add two or more lists together. Let's define another list as my list 2. My list 2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with my list2? So what I'll do, my list plus equal my list2. Let's see what is the result. Let's print the value of my list. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because I executed it twice. It's my fault. So what you can do, you can just mylist dot remove. Hold on. I don't want to execute this entire list of statement, so I'll define it under different block. So my list dot remove Python. Okay, I have misspelled Python as okay. Remove this. Again, remove this. And remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of times. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1 3.14 and Python. And we want a sublist from 1 to 4th index number, like 1, 2, 3, 0, 1, 2, 3 plus 1. 4th won't be included, so we'll get the output as 1 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right? It's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different strings. Alright. For example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want? For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position. And you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you're grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, 1 apple, 2 ball, all are taken as a pair element. Fine. Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, mydict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces, and you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. My set S2 consists of 1, B and C. So if I am performing a union on it, so it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1 2C, 1 BC. So we have 1 and C common in both the set. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set, and it will return the only value which is a unique in first set. For example, we have 1 2C in set 1 and 1 BC in set 2. So if you subtract it, so you have 1 in both the set, so it will emit it. 2 and B, so nothing can be done about it. C and C, again it will emit it. Now since only 2 is left in set 1, so you get the output as 2. Alright? Fine. So this was all about the data type in Python. So now that your base is clear, let's have a quiz. So what would be the output of the following code? Test1 equal Python programming and print test1 from 2 to 6. In order to know the correct result, do post your answer in the comment section below. Alright, so let's move ahead. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Let's see the flow of execution. You start it, you check the condition. If the condition is true, then execute block 1. If the condition is false, then go to the else part and execute block 2. Fine. Yeah, this block 1, it comes under if part. Alright. Let's move next. Let's move ahead. Next is nested if else. Let's see the syntax. If condition 1 is true, then execute statement 1. Else, if condition 2 is true, then execute statement 2. If none of them is true, then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition, that is else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, then finally the else block would be executed. That is execute block 3. And yeah, remember one thing, there is no condition associated with the else block. Else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterating variable in sequence, colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement. Again increment the value of count by 1. That is count become 2. And again check if 2 is less than 3. And so on, continue this till 10 is less than 10. And when this thing arrives that 10 is less than 10, your condition become false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright, we have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x. X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for x in fruits. Now x of 1 is banana. Then print x. X is what? Banana. So it would print as banana. Again, it will go back. X in fruit of 2 is what? Cherry. Print x. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code. Like a equal 1. In variable part I got a equal 1. While a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is, A is even. A in this case was 2, so 2 is even. Fine, so this is our output. Next, again it will go and increment the value of A by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here. For example, A equal 10. While A is greater than 0, check for if A is not equal to 5. If A is not equal to 5, then print A. Else break it. Fine. Let's execute it. Sorry. This bench. A minus. So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition. Alright, let me just show you. Let's just replace this break with continue and let's see what is the result. So yeah, see, got the output as 9, 8, 7, 6, 4, 3, 2, 1, but you didn't got 5 up here, right? Why? So as I told you, this 5 was skipped. Fine. So this was all about the flow control. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instructions that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by user is a user-defined function, right? Syntax. It starts with the keyword def, after that an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b and return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that I'll write a function name as add. Inside that I'll pass two arguments, a and b, semicolon, and this function should return me the sum of a and b. Alright, fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function, which returns the absolute value of a number. We have all function, which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def that is keyword. So we are defining the function as print the value of b is b. And again inside the function we are updating the value of b to be 100. And print the new value of b is b. And then what we are doing? Change it and we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you in order to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30. And the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2 inside this. D is what? Print the value of D is D. Alright. Next we'll define some numeric literals like D of 0 is equal to 99. D of 1 equals 98. And then print the new value of D is again D. Fine. This is my function. Now if I call my function using pass by reference, so my function 2, and I pass the value C into it. So let's see what we get the output. So we got the output as the value of D is 10, 20, 30 and the new value of D is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright. In pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Let's get back to the quiz and test yourself. The following function takes two parameters and print the first one. So fill in the missing code. Fill in the missing code. What is the code? My definition function takes first name, last name, and what it should print. So post your answer in the comment section below and get it verified with us. Alright. Next question is a function which returns the x parameter plus 10. Alright. So fill in the missing code. Define my function as x and write the entire function for it. You have to write a function which return the x parameter plus 10. And again, post your answer in the comment section below and we'll let you know if it is correct or not. Similarly, we have fourth question. What is the output of fruit? We have a tuple up here as fruit equal apple, banana and cherry. If mango and fruit, then print 3 plus 4, else print 2 into 2. Again, print the output of the following code in the comment section below with the question number. Alright? Fine. Now let's discuss about the lambda function in Python. So what is this lambda function? Well, a lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10, and then print x inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright, if you change 5 to 10, the output would be 20. Alright, let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes 2 arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 comma 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass 2 arguments up here, x and y, colon. Now return me the product of x and y. That's it, it's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass 2 values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n. So you are defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook. Define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it, so my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the lambda function. Fine. Let's test yourself. Write a lambda function that sums the argument a, b and c and then print the result. Note, post down your answer in the comment section below. Alright. Next quiz is, what is the output of f my function n, return lambda a into n, my doubler, my function 2, my doubler 11. Very simple, we just discussed it. So just post your answer in the comment section below. Okay. So this was all about the lambda function. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon, and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python. So coming to our last topic of file handling in Python. Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file, and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it will return you an error. Next is the append. And the mode is A. Alright. What it will do, it will open a file for appending. And in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine, I'll tell you about the difference of appending and writing later in this section. Alright. Next and the final one is create, that is X. It creates the specified file and it returns an error if the file with the same name exists. It creates the specified file and it returns an error if you already have a file with same name. Fine. Let me just show you. Like f equal open path of the file. I'll open it in my D drive. D slash name of the file test file dot txt and comma, what should be my mode? It is a reading mode. R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here and it will create your file. Let's go to our D directory and let me just show you the file. D. So you can see the test file up here, right? So this is how you can open a file in Python. Or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. Test file. Hello everyone. Welcome to IntelliPad. Good luck. Let's save it. Save it as testfile.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode R. R is what? Reading mode. And then print f.read. Fine. Let me just open that file for you. F equal open the path of the file. It was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f dot read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to IntelliPat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine which would be used to return one line or the first line. Again copy it. Paste it up here. Read line, just hit enter. Sorry, you got an error. Okay, read line. Okay, sorry, L is small. Read line. So you got the output as hello everyone. This is my first line. Next, what if I need to read first 2 lines of my document? So what will I do in that case? So in that case, what you can do, you can use read line twice. And it will print first 2 lines of your text like this. Again do it once more, f dot read line, hit enter. Again the same error. Okay, so what you got? So you got the first 2 lines from your text. Alright, now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to IntelliPat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f dot write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, let's check the existing file. Open it in a readline mode. R for x and f, print x, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use w instead of a? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen myfile.txt_x, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do, you have to first close the open file. So f.close, inside this, mention the name of the file, or the path of the file, d:/testfile1.txt. First close it. Sorry. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Testfile1.txt. That's it. Got the error. The system cannot find the specified file. So I guess the file is, no, it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Okay, let's get started with NumPy. So I believe you guys already know like what Python is capable of, how powerful it is. So we can use Python for all sort of things, right? From desktop development, web development till data science, we can do anything and everything with Python in the programming world. And next thing is Python builds upon its functional modules. Okay, so it has all core constructs of programming. Like there are 3 types of programming that we have: structural, object oriented, and functional. So it is capable of doing everything. Okay, next is when we work with anything in Python, we have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily. okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay. So after that, we will see. I mean, after that, we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to, I mean, play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with pandas and, I mean, NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, I mean Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am letting it again and again, pip install numpy. So it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing yes. So we are changing data type from mutable to non-mutable. It's the other one, right? Right. Next is ND array object. Okay. So in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in the real world, if you ask me, we don't use more than 2 max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use numpy arrays. So in numpy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to, it all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for numpy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? Sorry. So you need to do this. So you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming. Okay, I am working on 2D arrays. Sorry, I forgot. So that's how it works. Okay. So we will be coming to that in a few minutes. So 2D arrays, I will show you. So for others, what was the names? A and B, right? 2D arrays, I will be showing you. Not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print whole. If we do this, that also will mean the same and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now numpy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than numpy array. Okay, now next is if you go into check the individual. Yes, right. So it will be begin colon n minus 1. That is how. So right hand side will always be excluded like that. Okay. Next is numpy array initialization, right? So how do we initialize numpy arrays? As we have already seen, right? How do we do that? But still, this is how you do it. Okay. So initialize means what we want to do is we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing and for data processing, we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in numpy. So what you do, you write np dot zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np dot zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in numpy. So that's how you print zero arrays in numpy. Okay, next is if you want something with an interval, right? So how you do, you write like this, np dot array, within bracket we pass, so it will print you another new array. So what we are doing, we are sorry, in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's a range, so it's a range actually. Okay, so what we are doing, we are passing three variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having five, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have. So we have three numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go, okay? Till 20 we will print it out, okay? So that's how this kind of arrays are getting printed out in NumPy. So using this A range you can have other type of arrays also. Now this is the same thing, okay? Now next thing is this A range is done, right? Now let's say we want we want to spread some points over a straight line, okay? So how do we do it? We want to I mean, what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line, okay? So what we will do then, like we want some points between range A and range B, okay? So here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise, okay? We want it to spread along a line like this. So for between 5 and 10 we want 6 numbers. It is almost same as NumPy, but it has a bit difference. So how it is differing, I will show you, okay? So
Just
this
one
link,
doubt in the range. The last, the end number, can we put as 19 instead of 20 in the last example?
yeah, then it will print only single number,
No, no,
right?
no.
And
No, the second argument.
yeah,
Yeah,
this one
and
we can do. It will go till 18 only, not an issue.
okay, thanks.
Yeah, you can put anything. So the logic is, when it reaches the end number, right, with interval, if it goes past or if it goes till the last number, then that number will be I mean that number will be excluded, right? So let's say 18 plus 2 will be 20, right? So 20 will be excluded, okay? So that's how it works, okay? So for 19, 18 plus 2 is 20, so anyways 19 will be excluded, right? Nothing is there to print it out, right? So that's up. Okay, so we are not into loops, so I won't go in that. Okay, next is this linspace, okay? So linspace and arrange, right? So arrange, what it does, it takes in three numbers: so start number, end number, and so what we do in arrange, we have three numbers as a parameter. We take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals, okay? But in linspace, what we take three parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there, okay? Number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linspace and arrange, and all these functions we will be using heavily when we go for data science, okay? Because these things we will need, and you will see how do we do that, okay? These things we will be discussing when we discuss about the data science concepts, okay? Now next is how do we do array with the same number, okay? Next is how to create an array with the same number. So this is same for same uses, like that, like for zeros, right? Formats for carving out some masks, like that, okay? So if you use this keyword, then if you pass some values, so come on, if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up. So np dot full, it will take up first a tuple, the tuple of row numbers, column numbers, and it will take up the number to fill that array with, okay? Number to fill, like that. This thing works, this full function works. It can be anything, okay? It will give you a array full of that kind of numbers of any dimension, okay? Any dimension can be given, okay? Any real world numbers can be given, I mean, sorry, any integer number can be provided as a dimension, okay? So that's how this full function will work. Okay, next is to randomize an array, again for, I mean, that masking only. So how we do, Let's say we want a 3 by 4 matrix to be randomized. So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, and that way it will be organized. So random is this thing. Okay, now we go to how do we access this NumPy arrays. Okay, now let's say we are creating two arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do print a, so that's how the shape function works. Okay, that's how we can access a shape of an array. So shape function will return a tuple of its row number and column number. Okay, so a dot shape returns tuple row num column, like that. Okay, so it will be returning like this. Okay, now the next thing is, what is the use of the shape function? Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it and we can change the values. Okay, even now we can access like a, no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is happening? Okay, so we can access individual elements of the shape tuple that is being written like this. Okay, like we use like we access normal tuples. Okay, so we can, what we can do with this a dot shape, we can we can get the tuple, I mean tuple of row number and column number as an output. We can change the change the shape of the shape of the matrix with with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in a data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all. So that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just, I mean, sorry, for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay, one thing, so you guys are acquainted with I mean, you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back the zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's going to be
No.
one. Shape is always gives only the columns and rows here. So the 0 will give the rows and 1 will give the columns. That's it.
The column. So that is a tuple basic, right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
that
got
will be 0 1, like that. So it is an 1D tuple or 1D array, whatever you call it. Okay, so that's
Okay,
how it
thank you.
works. Okay, now we can have several more examples of np, I mean this shape function, but I am not going into the detail. But you need to remember one thing, you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3 it won't work, because the size of the array is total of 6, right? So we need to have it multiple of 6 only. That's how we can break, that's how we can reshape. Okay, that's what is about this shape function. Okay, next is how to get total number of columns. Okay, so again I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay, so that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values, number of points needed, will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function, it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that, like a shape function. So I will put it right in there. But the only difference, it can be modified. Okay, so where were we? We were with this endim, right? So how it will work? Endim will return you the, it is not, I mean, it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But endim will return you the number of dimensions of the array. Okay, so if you see the endim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2, 2 dimensions, right? So that's what endim returns. Okay, endim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So endim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is the d type. Okay, d type is to give you the type of each elements in the array. Okay, in the numpy array, it will give you type of all the elements, and numpy arrays cannot be heterogeneous, it has to be homogeneous always. So numpy arrays will return you, I mean the return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, I mean sorry, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this d type function. Next is how do we use it for maths calculations. Okay, so any doubts till this part, till this d type? Now if I show you something more, say, okay, next is as I have created now array with like float numbers. So you see the arrays are, the d type is printed as float 64. Okay, so you have you got an array of, I mean the d type as float 64. Okay, so that's how this d type function works. Okay, so and numpy, as the name suggests, it is used for linear algebra. Okay, so numpy is used for number mathematics or linear algebra. So you won't be really having string arrays in numpy. Okay, so you won't be having it, that is not provisioned. So numpy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is numpy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this numpy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how numpy summation function works, and it can add up to different things. Okay. Okay, so sum will return you a sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there. Yeah, it works, right? Why it is not working here? Sorry, I haven't put it in a list. Okay, so now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5 10 2 3, that means 10 5 15 and 2 3 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few flavors in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out A and B for you. Yeah, so see, A and B are 5, 10, 2, 3, right? If we do a sum with x is 0, that means it will do you a column wise sum. So that means 5 to 7, 10 to 13. Okay, and if you go for a row wise sum, then it will be x is equals 1. So it will return you 15 and 5, right? So that's how this will work. Okay, and a row wise sum, that's how it will work. Okay, so that's what is the so that's how this functions work. Yeah, that's how this numpy arrays or array sum function works. Okay, so that's how you can get the. Okay, give me a second. Yeah. Okay, fine. So this is not how it works, right?
Remove the
Okay, let
square
me.
brackets and keep only the circular brackets.
Sorry, no, not like that. It won't take it. Yeah, so x is 1, 5, 2, 7, 10, 3, 13. Yeah, got it. Okay, so two confusions were there. First of all, be like it, like x is 1, why it is not taking up? Okay, let me check for some example in the PPT, doing some casual mistakes. Yeah, that's what I have written, right? So 0, 0, 0, 1, 0, 5. So it should be 0 plus 1, 5 plus 0, that is 1 and 5. So it's fine, right? 0, 1, 0, 5, so 1, 5. Yeah, correct. 0, 0, 1, 5, 6. Okay, let me copy this exact example, what it does. np.sum with x is 1 having some problem. Just give me a few minutes, I will do that. Yeah, now it is working fine. 0. Yeah, now it's fine. So now if I replace it with A, I replace with B, if we remove this, as those are already list, how it works. Yeah, now it is looking good. Again, okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem, I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So sum I will discuss it later. For subtract we already have discussed. For this division also, it will work in the same way. Okay, what is it with someone? Sure. Check. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise, it will just take in two parameters and it will just divide to the numbers. Okay, row wise it will divide to the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay, similarly we can see the multiplication being worked on the same thing how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 10, 30, like that it will work. Okay, so these are a basic few functions that will be needed for our data science courses. And this expa, it will give you e to the power a. Sqrt, it is for square root. np.sign is for sign value of each of the elements. np.cos for cos value. log for log values. Okay, so these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this numpy. I am showing that to you. So these are not really needed for being a data scientist, so you can just check these values. Okay, okay, next is the element wise comparison. So we have So that's how element wise comparison does. So it will compare each and every element of the array with another one, and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you a output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np dot equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called, so it will give you a single value, okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of like a false or true or false based on the comparison results. Okay, so that's how it is. That's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now, if we have already seen this sum function, right? So np dot
Arrays
sum.
are of different dimensions when you use equal, array equal, or other things.
Sorry, you mean this, right?
Yeah, so no, I mean when you're doing an equal comparison, yeah, so how did it handle different dimensions of the arrays?
It won't handle, right? It will throw you an error because that is how matrix works in real world, right? You
Okay.
can't compare, you can't add, you can't multiply matrices of different dimensions. It has
Different.
to follow some rules,
Yeah,
right?
agree. Yeah, I remember now.
Yeah, so same things will do it here. So for multiplication, we have a rule, right? 2 by 1. If a matrix is 2 by 2, then the other matrix, the first one has to be equal to the second one of the first matrix, right? So 2 by
Yeah.
2 will go with 2 by 3, not with 3 by 2, like that.
Yes.
So those rules will apply here. Okay,
Yep. Thank you.
that is what the basic things of this. Okay, so np dot mean max, these are there. np dot mean. So mean, median, mode, standard deviation, this thing you guys remember? Because these are heavy terms that we are going to use for rest of our sessions. Too much. We will use this.
Statistics, yeah.
Yeah, basic stats. Data science is all about that, stats and maths. If you are good in these two, Python is super easy to learn. It won't take you much. And you just need to incorporate the thinking that how do we think as a data scientist. So these three are main things. Others will fall into its place. But if you have a good base in maths and stats, it will help you a lot. Okay, so what is it? Core QF. Okay, FF not. It's F. Come on. Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. I am forgetting this. If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array, so you can skip it safely. But again, that is a best practice to write it. Okay, so np.sum a will give you sum of all the elements, minimum will give you minimum, max will give you the maximum element, mean will be the mean of the elements. Okay, so mean means the middle element of the arrays. Okay, then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay, so that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay, so it will give you sum of all the elements, minimum of all the elements, max of all, mean of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not, let's not worry about it. So except this, have all these things clear. So that's how it will work. Okay, okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine. Mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail, you can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay, so that is like broadcasting. Okay, what is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay, yeah, axis won't work for this kind of cases. Yeah, okay, so let's say we have this kind of an array to work with. So the first array, if you see, the first array is of 3 by 3, right? So 1 2 3 and 4 5 6, it is in 3 by 3 array, right? The second array, if you see carefully, we have passed 4 5 6, only 3 4 5, only 3 numbers. So that array comes to be of 1
It's
by
2
3.
by 3. How is it 3 by 3?
Sorry.
You said the first array is 3 by 3. It is 2 by 3.
Oh yeah, correct. Thanks for correcting. Yeah, it's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3 4 5. Only 3 numbers are in there, so it is an 1 by 3, right? So now when you add it, if you notice it carefully, you will see the second row of the array is also getting added with the same number 3 4 5, right? So that's why it is coming 4 3 7 5 4 9 6 5 11. Okay, so how this is happening? This is the concept of array broadcasting in NumPy. Okay, so if you see in this diagram, what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down, it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. This broadcasting is also done for the subtraction scenarios also. Okay, so this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to a integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and it prints accordingly, right? So let's say for this Monty Python, we are going from 6 to 10, so that will take from P till H, right? Because 10 will be excluded. But when we go for -1, then we go from the larger number to smaller number, because as you know, for negative everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do a 6:10, that means that is from 6 till 10, like that indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1 2 3 4 5 6 and 7 8 9, if you go for A0, then it will print all the elements of the first row. And if you, so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking Okay, so these two things returns basically the same thing. Okay, so when we have A0, we return the first element of, I mean, the first row of the matrix. Okay, when we return A colon 1, what does that mean? Okay, so colon 1 is for the I mean, so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write colon 1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1 2 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and I mean list of lists. And the first one of A0, we are just simply accessing the first element of the first row of the array, first row of the 3D array, I mean sorry 2D array, and that's why we are getting 1 2 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see how what all things we can do. So A colon 1 extract till row equals 0. That means it is the first row that is reprinted, right? Now for the second part, if you remember the indexing and slicing thing, so the first one will account for the row and second one will account for the columns, right? So if we do colon 1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1 colon, that means give me all from the first column till last. Okay. So that's where we get this 1 colon will return you 2 3. Okay. Now if you remove colon 1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2 3 5 6 8 9. Okay, so that's how indexing and slicing works for numpy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So I will leave it up to you. You would need to answer this. Okay, so let me explain. This 2 colon means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only one row will get printed out, and we are giving colon 3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why colon 3 returns you 7 8 9. Now let me change it and see how many of you can answer. If we do it like this, what will be the answer? Colon 2, then 2 colon. For row it is colon 2 and for column it is 2 colon. So y3, y6 separately. Okay. So for row we have given colon 2, right? That means we want the second row, right? So colon 2, that means we want till the second row. So the first two row will come into picture, 1 2 3 and 4 5 6, right? Then we have given 2 colon, that means third element onwards, so 3 6, right? Okay, next thing is array manipulation. Okay, array manipulation is to stacking arrays. I mean, like, okay, so what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on two arrays and we are outputting a third array. Here also, we will almost do the same thing, but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so okay, the first function is concat. Okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally, and one is out of bound. It shouldn't be. Okay, we don't have any columns in here, right? So that's why column wise is not possible. But if we had 2D arrays, it will be possible. That's what I will create for you. It will be easier for you to understand. Yeah. So this is like column wise stacking, right? So this 1, 2, 3 in here and this 3, 4, 5 in here got concatenated together, formed a new row. This 4, 5, 6 and 5, 6, 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that, this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, let me print this matrices for you, it will be easier. So see, the first matrix is 1, 2, 3, second one is 4, 5, 6. When we do row wise concatenation, right, we just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay, now if we go for column wise addition, column wise concatenation, then what it will do, it will concat the columns on its own. Okay, it will concat the columns on its own. Okay, so then it will give you a new row output. Okay, so that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in, because this is column wise now, so that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay, so that's how the output, array output will look like. So the columns will be concatenated to a row. Okay, so that's how this concatenation works. Okay, that's how the concatenation works. Okay, so this is what is about this concatenation property. Okay, next is vstack and hstack for numpy arrays. Okay, so what is vstack and what is hstack? As the name suggests, vstack is vertical stacking. Okay, and hstack is horizontal stacking. Stacking means the same thing as concatenation with a bit with just a small difference. Okay, that we will discuss now. So before going into vstack, what I will do, I will show you stack example. Okay, there is another function called stack in numpy. Okay, so I will show that first. Okay, before going into this normal thing, this hstack and vstack operations. Okay, so what it will do, for these two arrays only I will consider. So let's say I am stacking a and b with x is 0. So I am stacking a and b on x is 0. Okay, so it is not a list I should pass, it should be a tuple in here. Was what is happening? Okay. Sorry. This one is there, this one is here. Yeah. So this is how the stacking looks like. Okay. This is stacking horizontally. Okay. And if I go to x is 1, this is stacking vertically. Why the array is not changing at all? Have I changed it? No, right?
It is changed, Abhishek, for the axis one.
Is it? Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1, 2, 3, 4, 5, 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, now I'm having some kind of a problem in here.
So you're not running it again. You need to run it again.
Yeah, I ran it, but still it is not working. Not sure why.
It's
But this
working
is not
for us.
returning in the proper stack also. This is not how it should return. That is again a problem. Let me try with 1D array once. 1 second. Yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay, so in horizontal stacking we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see, in the row equals 0, the output is 1, 2, 3 and 3, 4 columns. So the two 1D arrays have gotten into a sequence, row wise they have concatenated. But when it is going for column wise, then for 1D arrays it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay, this stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. Okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created, I mean, stacked array of its own, like of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay. Now here on the contrary, if you see the hstack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this h stack and v stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is okay, let me write it. So let me do it a bit clearly, give me a few minutes. Print vertical concat vertical stack. Okay, let's see the differences. Okay, now x is 0, x is 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1 2 3 2 3 4 concatenated in a same row, 4 5 6 5 6 7 concatenated in a same row. Okay, and return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row, and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased and those elements are stacked into the columns. So 2 5 3 6 4 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for H stack, V stack, and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a missed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like. I will show you. Stack, forget about it, it won't work here. So this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4 are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4 5 6 and 5 6 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we are concatenating the rows to the entire matrix. So 2 3 4 5 6 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked in the rows at the bottom of the older matrix. Okay, for vertical stacking, it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation, it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about these four operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides. So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking and there. Okay, that is how it works. So that is not much used, column stack function. Pardon please. So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, I'll show you here. The syntax, how it tells is, for this split function is np dot split. Okay, it takes three parameters into account. First one will be a array, it can be anything. Next one will be index, this I will explain. The next one is axis. Okay, the array, the first one can be any numpy array. Okay, it can be any numpy array. Indices has two forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be that array will be splitted from that row. Okay, split it from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is access. As you already know, that is having 0 and 1. That is the same thing as you already know. 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this A array. Okay, so print A, this will be our A array. Now what we will do, we will split this array. So A, the first, second one I am passing an integer, third one I am giving it a column. So see what happened, I provided 2 as an integer value, right? So the array is split onto two arrays. Okay, if I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay, why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here. So we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits. So the 2 arrays will be coming out. Now we are splitting it based on x is equals 1. So that means a columnar way. So we have 3 columns. So it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. Critical thing is coming up for you guys. Now let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay, so this is how it will differ when you pass this, like when you pass this pass a list to the integer value. So the array here will be split into 3 parts. Okay, and then those 3 outputs will be given. Okay, so in the list, the first one is an the first thing refers to the column. So the array will first be split into a colon 1. Okay, then the array will be split between these two numbers, that is 1 colon 2. Then the array will split for the last number, that is, sorry, the array will split into the last number, that is 2 colon. Okay, so this 3 thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has 3 elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these 3 parts. That's how split works. Okay, so this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now if we go for column wise, you see something different, right? So what is this doing now? Here everything is given for only row, right? But here everything is done for column. Okay, so see, the first output is 1 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay, so now if you see carefully, these are the splits that you got in there. Okay, 1 4 2 5 and 3 6. Okay, these are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into 3 parts like this. Okay, and then you concat the output of these 3 separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is. What is the advantage of numpy over list? Okay, so this numpy arrays consumes less memory. How? We will see in the next few minutes. Next is, this is faster. We will see an example that how faster numpy arrays can be. And next is more convenient. As you see in list, you didn't had all these methods, right? Sum, min, max, median mode, this concat, h stack, v stack, this all these methods that we have discussed till now. We needed to write those on our own. We need to do this on our own, right? So these are the that's why numpy array is more convenient. And as a data science, and someone was talking about pandas. If you know about pandas already, or if you have read about somewhere, pandas array is all only based on numpy array itself. Okay, it is same thing. Okay, pandas array and numpy array will go hand in hand. You will see. Okay, so if you understand numpy array better, it will be easier. It will be cakewalk for the pandas part. Okay, so that is what is about this array part. Okay, that is what is about this numpy part. Without wasting time, I will go into an example first, then I will come to this one. Okay, example will be somewhere down there. Okay, this one. This is a quick example how it is advantageous based on memory space and how it is advantageous based on its accessibility time. We are having time near equals 0. Sorry for that. Let me increase it. We have another 0, another 0. Okay. So see, here is the example for memory size. What we are doing, we are defining a list, right? Range function returns a list, right? We all know. So we have taken a list here. We are getting size of 1, that is 1, and we are multiplying with len of L, right? So 1 is an int, so it will be, so what is why 1? Because L will return a range of range from 0 to 1000, right? L will return that. So 1 will be the element and it will be int. So that's why we have written 1 here, and we have written len of L. So that means L has 1000 elements and it will take 28 byte for each element to store. From the list basic, you must know this. So that is why it is printing as 28,000. Okay, for that it is printing as 28,000. So for storing 1000 elements in a Python list takes up 28,000 bytes. Okay, whereas for a numpy array it takes up only 4000 bytes. Why is that difference? So as you know, a dot size is, what is a dot size? A dot size is the length of the array. A dot item size is size of the array stored in the memory itself. Okay, so size of the array stored in the memory. So that's what it gives us, 4000. So that is coming as 4000 bytes. So why is that difference? Okay, why is that difference? Why is this huge difference? Now let's go to this PPT. So see, for numpy array, how we store, we directly store the data into the pointer. So forget about this dimensions, right? Focus into this data. So this is a numpy array where we have a data head, and the data head points to the data directly. Okay, data directly. So as you might have covered in the list basics, how lists are stored in Python is not directly. Lists are stored on some memory location, and that memory location is returned to the list element. So that's why that is an mutable one, because you and tuple is an immutable one, right? Because in tuple you can change the value, because it directly stores the it doesn't have the memory address of it. It is an immutable one. But in list you will have the memory address stored in it. So whenever you access some element, it is accessing the same memory location only, not the direct value. So again, that memory location will have a value. So for storing memory location, it will consider 2 bytes, and for this it will 14. So 14 by 2, 28 bytes for a single memory location it will have. Yeah, list will be having two step of data storage. So first one will be a pointer, second one will be a data. Okay, second one will be a data. And no, numpy is not immutable. Numpy is mutable. We have seen multiple examples, right? Numpy is not immutable. It is not because of this storage that is immutable or mutable. That's what is considered. It is due to some other features. This is just a language construct. So they have made tuple to be immutable, and tuple doesn't store it like this. Okay, numpy is not immutable. Numpy is based on list only, so it is totally immutable. But the storage of data is different. It stores the data directly. Okay, But for Python list, it stores the data in a two ways. Okay, so 14 by 2, 28 bytes will be taken up for a single memory location. Okay, so that's why that's what you saw in the example also, right? In a programmatic example, you have seen it. So that is how it is beneficial from the memory location. Okay. Now, if you see, we are doing some XYZ operations, that is adding to list. First adding to list and second adding to NumPy arrays. The same thing we are doing. Okay. So here we needed to pass it through a loop, right, for adding. But here we don't need to do that. We can do a clear matrix multiplication by a plus b, and then we are returning the time difference. If you see the time difference here for NumPy for normal list is 0.005. Okay, but for NumPy arrays it is 0.000999, something like that. It is too small, because when I was doing it for 10,000 for my machine and configuration, for 1000 actually it was not even coming something. It was coming in a zero value first, not for 1000. And see, even if you see for thousand lists, 1000 values in list and 1 lakh values in NumPy array, still NumPy is somewhat faster than list, right? If I do a 1 lakh in both, you will see that real difference. You will see it is 41% faster than a NumPy array. Okay. Now, if I just reduce a zero, it is coming in the range of zero. Okay. That's how lightning fast NumPy array is, because in NumPy array the access is direct, right? So that is just going into the location, fetching the data and doing the addition or multiplication or whatever you want to do it. So that is what is being done in NumPy arrays. Okay, that is what is done in NumPy arrays. So that
But one
is,
question, like without
yeah.
memory location, how it identifies actually in NumPy array?
In NumPy array, the object is directly stored in the memory location. Okay, I mean in the RAM, right? In the RAM, in a block, it is directly stored. So NumPy contains a data head that directly points to that memory location. Okay, but for Python, the items are stored in some other place, and the address of that place is stored in the Python's item head. Okay, so memory location is there for NumPy array, but the storage is direct. It is one level storage. Okay, it stores the data directly into the memory location. So it is like in your RAM, in a RAM cell, putting in a direct value instead of putting in another memory address in your RAM location. Okay, so and in that memory location you will find the value. So that's how it works. Okay, so that is what the difference between this NumPy storage and like a normal Python list storage. Okay, and for the,
And one more question: is it going to store it continuously in case of list and NumPy? How it stores? Is it going to store continuously, or in the list it will store randomly?
it will get the memory location from the address bus, right? Whatever it gets, it will try and store over there. So there might not be any other pattern, because RAM, it anyways it won't contain lot of values, right? So it depends on the computer system, right? How it allocates the memory to the Python compiler, it will keep on storing like that. So you can't control how your, I mean, Python can't control how your system works, right? How the address bus or how the CPU works, it can't control that part, right? So it based on the entirely based on your system itself. Okay, so we can't really comment on that, how it will be stored. So when you run Python program, if you want to know the backend, what happens, a request goes into your CPU sees if what kind of request it is. If it's a write request or a read request, it takes in the request, it sends into the processor. The processor then processes the request with the help of all the hardwares and the RAMs and all the address buses and the data buses that the computer is connected to, and based on their addresses and their availability and all, it gets written into the location. Okay, it is not really Python doing it, it's ultimately runs into your CPU only. So that's why having a stronger core is always important for data scientists. Okay, like stronger I mean that processor actually, that's what. Okay, so that's how it works. Okay, so that's what is about this NumPy arrays. So let's get started with this pandas module. Pandas module is for data wrangling or data manging purpose. So what it can do, it can read you a file which will in turn and you can access the data in a lot of variety of ways. This will give you a label and all. So that's why pandas is used. Pandas is basically used for data manipulation purpose. Okay, it doesn't have any machine learning algorithm in this package. We just have the basic stats methods like mean, median, mode, correlation and all, interquartile ranges and all we have. And what we have is we have different functions for reading a file, different method for accessing different kind of columns and rows. Okay, we can do indexing and slicing on pandas, arrays, and data frames. So we have different kind of scenarios. Okay, we can perform a skill like operations in pandas also. So that's where it is beneficial, and it is basically used for data manipulation. So let's go ahead with this and see. So what is pandas? As I already told, pandas is a Python module. So that is open source one, obviously. So why Python is so popular these days for data science and other things is that it has a wide range of libraries which helps you to get basically anything done in few minutes. You no need to write the codes from the beginning in order to get the things done. Okay, you will get many open source packages available in the market, and they will be absolutely free. No charges will be there for using those, so not an issue. So you can always use those packages. You can write it on your own, but I mean, when something is already developed for you, we won't be that won't be required, right? So you can use that package. Okay, you can use that package. So that is again a very big point for using Python for data science related applications, because when we cover the machine learning algorithms, if you see for I mean implementing a basic of it with some good amount of result, it will take a huge amount of time if you don't have the packages. So Python has those, and those packages are really easy. You just need to understand how the algo works and how you need to use it. Okay, you don't need to write the entire algorithm. So that's why Python is again very popular. And for today's pandas module, this has many functions, many things related to data manipulation and data analysis. So that's why we use it, and it's open source. That's the main reason we use it. Okay, so let's go ahead and let's see how this pandas works. Okay, how this panda was derived actually. So this pandas name was derived from the word panel data. Okay, what is word panel data? That was some kind of a tabular data that has multi-dimensional data in it. Okay, and it is kind of a time series kind of a data. So when I say a time series, what does that mean? That means, let's say we are having like male female ratios for last 5 6 years. Okay, or male female income ratios in last 5 6 years, the example that is given here. So those kind of data is called time series data. See, for 2013, for a female age 23, salary was 20,000. In the next year, it got increased by 5,000. Next year, 10. Next year, 7.5, like that. So this kind of things called a time series data. That I mean, where we have a series of data. So the state of the data differs with the time. So that's what is called a time series data. And this is something like that. So for while analyzing that, this pandas module was derived by this guy, Wes McKenney. It was derived in created in 2015 actually for ease of use. And this is basically built on top of the Python list dictionaries and NumPy arrays and dictionaries. Okay, so that's how this pandas module was created, and these are some basics. So that's why you need to have your Python basics crystal clear in order to grab this pandas module. Now let's go ahead and see what are the features of a pandas module. Okay, first is series object and data frame. What does that mean? So pandas can support multi-dimensional data, 2D data, and one-dimensional data. All these three kinds of data are supported. Okay. So for 1D data, we have a series object. What is it? We will see that in a later. But just for an review, just for an overview, series object, you can say it is a 1D array of NumPy. Okay, a 1D NumPy array is almost similar to the series objects. How they are different, what are different, we will see in a few minutes. Next is data frame. Data frame means a tabular kind of data. Okay, so it will have some labels for the columns, it will have labels for the rows. You can have it, you can create that kind of 2D data. So how it works, this is a tabular data, right? So this mpg, cylinders, displacements, horsepower, weight, acceleration here, those were stacked into columns, and all these rows have had indexes. Okay, so that's how pandas module can read the data. Okay, that's how pandas module can read the data. So that's where the data frame comes into picture. Data frame is basically for handling two-dimensional data, and for 3D data we have panel data, but we don't really use 3D data nowadays because That's kind of things we still don't get. That is basically for videos and all, where we have layers of data, right? Pixels are layered, so those kind of data we don't really get it in data science. I mean, video analysis is only used for traffic police purpose, not much, and others very high-end jobs that will be using this kind of data. So for normal usage, we don't have it. So what we have is basically 2D data. So data frame is the thing that we are going to use more frequently, and series object is the next thing that we are going to use. Okay, this is for 1D and this is for 2D. Okay, next is handling of missing data. So what does that mean? We had some NA values in the data set, right? So we cleaned it. So how do we clean it? We fired up one command of pandas and it filled in the missing values with the mean of the data set. So handling of missing data is also gets very easy for using pandas. So that is again a good feature of pandas, which will give you a very handy functions to replace missing data or null data or the rows if they're not there having null values, NaN values like that. Okay, we will see those shortly. Next is data alignment. For what this means how you access the data, how the data is placed in pandas data structure, that plays a vital role. Let's say for the Python, for the XLS file that I have shown you a few seconds back. So for that, if you had to have all the list, all 1D list stacked into different parts, and if all different lists for arrows, different lists for columns, so they are all pretty messy, right? And it will take a lot of space to store those data. Also, it will be really hard to get the data, get the required data that you want to have, right? So that's where pandas makes your jobs super easy. That's where we use it. Next is group by functionality. So not only group by, we have group by, pivot, and all those functionalities is pandas module, which will help you to also join, merge, and all those kind of things are possible in pandas. So without having a database, without having a relational database, you can still perform this kind of operations in pandas module itself. Okay, so that's how you won't be able to write select queries, but again, the data set, if you see, you can select the columns as you require, and all those kind of stuff is possible. Okay, so that's another good feature of pandas that we will be seeing in a few minutes. So next part is slicing, indexing, subsetting. As I already told, like this slicing, indexing, and subsetting is a core thing that pandas does. So because this is basically based on Python and NumPy list. So again, this is widely used, and this indexing and subsetting will be used a lot. Okay, so that we will see later on. Next, if we go merging and joining, I have already told. Reshaping means you might not need some columns, you might not need some rows, so you can drop those easily. You can reshape it. That will be pretty easier. Hierarchical leveling of access, that means you will have a properly defined structure of rows and columns. Accessing those rows and columns will be very easy, you will see that. Next is robust input output tools. What that means, input you can provide XLS, Excel, SX, CSV files, text files, everything to pandas. It will grab those and it can convert the data frames and series objects to Excel file also. Okay, let's say you are processing some data. Let's say we have a Titanic data set. We need to predict the output of who survived and who didn't. So you predicted the output, but you need to present it to client. How you will do it? You can just have that data from data frame and write it to Excel file, and you can show that to your client. Like let's say this is the data that I got. This was the training data. That's what I did. I have some algorithms behind. Those I am not gonna share to you. What I can show you is how the output looks like, and output looks like this. So what you will have all the columns in the train data plus the survived column to check who survived and who doesn't. Okay, so this is that's what is benefit of pandas. It can save the output files in one liner. You can just have a one line. You can select the data into Excel file, in a CSV file. You can also name the sheets, like which sheet you want to save. If you have more than one sheets in the file, then also it will work. You can read that way also, you can write that way also. It has very robust tools for doing that. Okay, very robust functions are there, where all functions are available, so you don't need to worry about it. File handling gets easy with pandas. Next is time series specific functionality, again that I told in the first step only, because this is the base of pandas. So from this requirement, this was derived. So this can always be done, right? So this is again a very good feature. Pandas versus NumPy, what is the difference? So see, NumPy, what it has, it has homogeneous arrays, right? With 1D arrays with only numbers. But Pandas, where they are preferable when you have heterogeneous data. Okay, so let's say you want to accommodate strings also. It might be case that you want to have strings. You don't want to always convert it to numerical thing, but the reality is for the features of machine learning you will have it, but sometimes you will need to do a text processing also, right? Text mining also you might need to do before going to it. Let's say you have a very large description field, so you don't want to check all this, right? So you want to check for some specific keywords in that, so that's where these things comes handy. So it might be the case the data set that you get, you have some comments filled in there and you need to analyze that comment. Let's say for Twitter, for sentiment analysis you might need it. So that is again not data science, but that is a part of data analytics, but still somewhere you might get that requirement. Okay, so that's where pandas will save you, because in NumPy you won't be able to process the 1D, I mean the string arrays or more than 1D arrays. Okay, you can have multi-dimensional arrays, but again accessing will be difficult because it won't have named columns, named rows like that, so it will be difficult. So that is a real world case when you should use pandas, and when you should and this NumPy thing won't fit your purpose. So next thing is pandas perform better than NumPy for 500k and more. This is just number, this is just a number. We will show you like why we are telling this. We will show you at the end of the lesson, so you will see an example like how much time and space it takes and all. Next is pandas series object is more flexible, as you can define your own label index. That's what I was telling. So you will have a labeled index for rows and columns that you have. So you're accessing your columns won't be always based on integers, okay? Whereas in NumPy, you always have integer positions, right? But in pandas, you won't have it. You can define. So you will see that how it works. You will see that. Okay, so that is what is about pandas. Now next is how to import pandas in Python. So you can write this function import pandas as PD. So that will import pandas for you, and it will have an alias name of PD, which you can use it in throughout your code. You can give anything as alias, but PD is short and so short and sweet. So you use it. So you need to refer pandas module by using PD dot like that. Next is what kind of data is suitable. So as we already discussed, tabular data, arbitrary matrix, any matrix can suit this, right? And you can change this indexes and columns. And time series data. This was what I was talking about, time series. So see, a series of time will be given, and based on that, the changes of values will be given. So this kind of data suits pandas the most. Next is data structure in pandas. Before going to that, I will show you how you can install it. So in Anaconda, we will by default be having this pandas module. Okay, we will by default be having this pandas module installed. In that case, you won't be need to install pandas separately. But if you are having standalone Python installation, then how you can do it is you can use this command to install pandas. Okay, if you are having any standalone distribution of Python, not the Anaconda one, then you can use it. Okay, so you need to set the path for this pip command, and then you can install pandas. Okay, so that's how you do it. So that's what is about this pandas things. Now let's get started with this data structure in pandas. This I have already told. So in for one-dimensional data, we use series object in pandas. Okay, we use series object. For multi-dimensional data, we use data frames, and for 2D data, actually, we use data frames, and for multi-dimensional data, we use panel data. So this is not in scope. This we don't use it. So it's very rarely used, this panel data. So we will concentrate on first two, series object and data frame. Next is, what is series? Series is a dynamically labeled one-dimensional array. You can think it like that. So it can contain similar or mixed type of data. That doesn't hurt. Okay, you can have any kind of data in there. So see here, when we have, okay, so how do we create series object? We used to use this notation. Okay, so pd dot series, within brackets we need to pass in the data type that we need to convert to series. Okay, let me show you what happens if we pass 2D arrays. So see here what it will do. This will convert your data, whatever you pass it, to a series object. Okay, what is a series object? That means it will label your rows using integer indexes, and it will give you the data. Okay, so if you see, when I provided only one list, so what it did, it converted this list into a series object, and it had 1 2 3 4 5 written separately. But when we provided two lists, right, so our expectation was to get a two-dimensional matrix kind of thing. Instead, what it did, this series object taken those list as an individual element and columns. It put in the column values, and it provided indexes to the rows, right? So series object is strictly for 1D array. Even if you pass 2D arrays, that will also be changed to 1D thing. So series object is always used for 1D kind of an operation. So always keep in mind, don't confuse it with the data frame, because we are going to see data frame next. So they will look the same, but it is not same. Okay, so this thing you need to remember. Okay, now if you see the type of the series, if you see type of this series object, you will see it will be pandas.core.series. So that's where it comes handy. Okay, so you can check it like that. Next is the series object is done, so it will be of type pandas.core.series.series. Okay, so that's how it will work. Next is how to change index names. Okay, this was what I was talking about. So that means, like you saw, we had the 0 1 2 3 index kind of, I mean integer kind of labels attached to each row, but now you can change it to anything. How do we change it? You can, when converting this array to a Python series object, you can change it here. Okay, you can pass in a list of names here. Okay, so we have 5. Let's say we are providing 4, and if we run it, see here what is telling, length of pass value is 5, index implies 4. So what it will do, the list of index that you give, it will map it to those indexes. Okay, the index that you give, those will be the label for the row, and that sums this up. So this one will be mapped to each of the rows. So a b c d e will now be the row objects. Now if you try accessing this, so this will work. Okay, srs a colon c, now this will work. Okay, this will return you the values that you have. Next thing to remember, when we are using string based indexing here, it won't be excluding the right hand side. Okay, because it can't, right? But if you use integer based index, the right hand will be excluded. But for this kind of things, this kind of string based indexing, it won't be excluding that. So that's how it works. Okay, so renaming is done. Let's see how we can convert all these three types of data into scalar. I mean, two series objects. So we can convert this array to a list, dictionary in the similarly you can do scalar data also, you can do it. Okay, similarly this dictionary will also be converted, and scalar means a simple 1D thing that is also been discussed. Okay, so now the series part is done. So what is pandas data frame? That is basically a two-dimensional labeled data structure with columns all of potentially different types. That means any tabular kind of data which will have 2D data, two-dimensional labeled data structure with columns of potentially different types. What that means? That means you will have row labeling and column labeling. Okay, so this column labeling, so you can use it instead of 0 and 1, you can have labels for columns also, and those columns can contain different kind of values. Okay, one can have string, one can have int, one can have float, anything it can have. So that is where data frame comes into picture. Now why data frame? Data frame supports different type of columns that I just told, right? So you no need to have, I mean, you no need to have a single, I mean, one only homogeneous data when you are using this, like when you are using data frame. Okay, so that's where it helps you in getting in getting things done easily, right? Because when you are reading an Excel file, you can't expect that everything in there will be of some of the same type. It can have different types of data, right? So that's where this data frame comes handy. Next is mutable size. That means you can change the size. It is not immutable. It is mutable. So you can change the size and shape of the data that you get. So you can drop, you can create extra columns, you can drop columns, you can drop rows, and everything you can do with this data frame. Next is labeled access. This has already been discussed. So arithmetic operation in rows and columns. We will see how you can get meaningful information from the pandas package, pandas data frame. All the stats information that we saw in the last classes, like in the SciPy that we have seen, in the NumPy we have seen, we have same set of information available through this pandas object also, because this is basically built on top of this NumPy arrays only. Okay, so you will see how you can do this. How to create data frame? It is the same way, pd.dataframe.data. So list, series, numpy, nd, array, dictionary, anything and everything can be converted to a data frame. Okay, now let me show you again. See now, what is the difference from series and what is difference from the difference in this? You have a index in column also. Now let's try this. See here what is happening. So as you have provided two columns with different set of values, that's why it has put in none, nan, when it didn't find any values. Okay, so what you had 5 columns in here, right? You have 3 columns in here. Let's say I am changing it. So you provided 3 in the first one, and 5 in the first one, 3 in the second one, right? So when it tried to map the second row of the data to all these 5 columns, like in the first row it had 5 columns, right? Because you have specified 5 values. So in that case it found 5 values, it printed all those out. In the next row, when it had 2 3 4, it tried to map all those to 5 columns, but instead it found 3 values. So what it will do with the rest, it will put an NaN in there. So that's how this pandas data, I mean this 2D arrays has been mapped to a like pandas object. Okay, now let me change this to dictionary right away. So here if you see, I have put in a dictionary, right? A and B. So A, B are converted to columns and others have been changed to row indexes 0 1 2 3 4, and the values are mapped to this columns only. Okay, values are mapped to columns only. So that's how this thing can be that's how this thing can be changed. The dictionary is changed to this kind of a 2D data frame. So that's how dictionaries can be changed. So here what it will do, this there are 3 values, right? So it will convert to 3 columns, and here we have only 1 value, so the other columns will be converted to NaNs. But here we have 2 columns with 5 rows, so that's why it won't be containing nulls, and you need to provide both this value part to be the same size, otherwise it won't be converted. You will see some kind of value error. So that's why. So this if you have 3 values for the second one, that's what I just explained. So what is happening in this case, it is taking 2 columns, right? And it is filling out rows. So while filling out rows, if it doesn't have the matching number of columns, I mean matching number of values in the columns, it will throw an error, right? So that's what it is doing. So it is not, now it is filling out rows, it is not filling out columns. So you need to have full columns in order to provide the values. Earlier it was taking into account the column values where it put in null, but I mean NaNs, but here it is filling out rows based on these A and B columns. So that's why it should be equal. That's why it should be equal. So that is the concept. So we don't generally have this kind of values. We have, I won't say we don't have, but we don't have generally this kind of values for dictionary. I am just showing it for illustration purpose. So for filling rows, it can't fill a names because we don't know it. So that's how it works. This is a real world thing where we use this dictionaries. Okay. So for fruit we have some values, and for count we have some values. So that means we have 10 apples, 12 mangoes, and 13 bananas. In that case, it will show up nicely. Okay. The example that I have taken, it is something else. That's why we use it. So basically, this column A is a series, column B is a series, and this entire thing is a pandas data frame. Okay. So individually, all the columns are a series object. So when you get into this kind of a zone, you will be using the renaming of index. So here you can change this index name A to a fruit or something like that. So that's where it goes. Okay, we will see some examples on that also. Okay, so this basically sums this up. So this is for converting series objects. See here we are providing names separately. So you can give names like this. So what we are doing, we are creating a series object with A and B name, and then we are passing it to this df, and df is having this AB612 values. Okay, like that. So numpy arrays also you can pass it to there. So 2D arrays I have already shown. It can be of different types in here. So this kind of dictionaries you can put. So that also I have shown. So that's how this works. Okay, that's how this data frames can be created from variety of things. So that's how you can convert different kind of data types. Whatever you see in and around Python and in and around this NumPy and SciPy, you can convert all of this to a all of this to a data frame. Next is this inner merge, inner join, left merge, left join, outer merge, outer join, right merge, right join. So this is basically to concat two different data frames. No need to worry, we will see all these examples in a few minutes. Okay, we have a separate section for this. Starting from this slide, you will see a lot of examples. How do we use it and how do we do that and all. So plan is to have it after the break, or let's see how it goes. Okay, so till this slide, any doubts you guys have, or we can proceed. I think I have answered most of the questions in chat. The chat window is really small, so if I missed something, just let me know. Okay, I can repeat that also.
Abhishek, can we rename the index of rows? That is by default is coming like 0, 1, you know? So can we rename it?
Yes, but that's of no use, right? So you will, when you are accessing the Python object, you will max of the times you will use it based on columns only, right? Rows are not that much used, but you can do that. That's an option. Okay.
Okay. Okay.
But just think of it. Do you really need to rename an index, or 0, 1 is perfect, right? Columns are fine. Columns you will need here and there. So I can show you also. That's not a problem. So you can, okay, let me show you. You can pass in a dictionary actually, and you can do it. I will take a small example. I won't do it big one. So what I am doing in data frame, we have a thing called columns object. Okay. So when you do that, like when you check, when you after you create a data frame, you can access the columns of the data frame by using this keyword df.columns. This is a cheat code. So that is a list. Okay, and this is mutable. So you can assign the number of that values you want to specify for each columns, and it will be renamed. Okay, so this is a mutable thing. So that's why this way it can be used. Yeah, so that's how you can change the column names. Okay, so this is how the syntax is. So the thing is, if you want to change the indexes of a row, if the row labels you need to change it, then what you need to do, you need to pass in the 0 and 1, that is the row indexes, and create a dictionary. You can pass it in the index parameter of the df.rename thing, and there it will be changing the rows based on the it will be changing the row indexes. Okay, but if you want to change the columns, then you need to pass in index equal to string or int, something like that. So this index will contain this index, okay, the row indexes. This will contain the row indexes. Okay, then you need to pass in columns list. So this becomes same as this, df dot columns equals list, or columns equals a dictionary, the older name and new one, and the new name. Okay, and then this in place equals true. In place equals true means it won't be creating a new one, it will replace that existing thing. Okay, so that's why in place equals true, and then if you execute this, so it will rename the columns. But in real world, using this one is really easy and really helpful. So what you can do, if you I am not going into map now, if you use map, it gets easier. So for call in df dot columns, if call equals let's say 0, then you change it, it will be a here, right? So if it's a, then have it call equal to b. So if you run it, this will, this will change the column value. Now then you can go back and assign this column value to this df dot columns. You can create a list here, you can assign that list to df dot columns, like that you can do. Okay, so that's how you can do it. So you need to take another list, let's say call list equals this. So after you come out of the for loop, you change it to, let it be a, let this rename first. See, now a converted to b, right? So this is the best case where you can use. This will get clumsy as the number of columns grow in, you need to remember all, you need to rename all, so this will get clumsy, this syntax will get clumsy. But in real world, how I use this one. Okay, so that's how I use it. So this is the this is how you can do it in real world. This will be easier, right? As you can see. So if you want to change it, this will be much easier for you. So it can be anything. Okay, so 0 1 2, and you just check the conditions, you can change it like that, you can do it. Okay, so this is just to show you how it works. Okay, so that is what is about this row and column accessing. So now next thing is what is inner join. Inner join is joining two tables based on the common column, and the common column will be absent in the resultant value, right? So that is what is inner join. For right join, what happens? The right side table will come in entirely, and the common part of the right side table will have and will be coming entirely in the result, and the non-matching values of the left side table will contain null values. Okay, left join, it will be just the opposite. Left hand side table will be coming entirely, and the non-matching values of the right hand side table will have null values. Outer join, it will have all the data of all the tables, and whatever is not matching, it will put on null, right? So that's what is about this joining. Okay, so now all this can be achieved using pandas. So see, this concat thing that is being shown in here, I will show you with an example. So the concat thing that is being shown here, so that is something like, okay, so that is something like outer join. So that what concatenation does. Okay, concatenation, what it will do, it will concat all the data frames that is passed as an object to it. It will be taking all those and it will merge all those three data frames. Okay, so that's how this concat thing works. Now for right join and others, what I showed, so that will work similarly as it works for this one, right? So for that, we need some good kind of data sources. Let's say we are creating, I will keep it short, I will keep 2 columns only. What do we have here? This is my first DF. This is my second DF. Okay, we have a common column of A. we have a common column of A in there, right? So if we do concat, let's see what happens. See here what happened, it just concatenated the values, right? The C column in the first table is NN, so it has put in NN there, but B column in the second list is NN, so when it concatenated the second one, it passed in NN in there, right? But it has kept in the entire syntax perfectly, right? Entire values are kept perfectly. So that is what happens when you use concat. Okay, so concat is kind of a inner join. Okay, concat is a kind of inner join. Concat is kind of a outer join. So inner join, if I now show you what we need to do, it will be done using this concat command only, and we will have something extra. So we will pass in the axis value. Okay, so axis means the column, one means the column, right? So we will pass in and we will type what type. This is now inner join, right? So A, B, A, C is there and all the common values are present only. The values where it was not matching, those are removed, right? So this is what is about, oh sorry, axis one means row, right? So if you using columns, then only the common column is came out of it. So between A, B and A, C, only A is common, so A column is came out. So we are passing 0, right? 0 means the row wise and 1 means column wise, right? So we have passed in 0 here, so we are getting this kind of a result. So this has joined it row wise. Now if we do it using 1, so it will just concat those rows, right? So that's how it works. Okay, so 1 2 3, the first data frame was 1 2 2 3 3 4, second one was 3 1 4 9 5 10. So here 1 2 3 1 2 3 4 9 3 4 5 10, it has concatenated based on inner join principle, right? So this is I mean this follows the basic rule of inner join, but the difference is, unlike inner join, it won't give you the exact format of output. So for that we have some other things that we really don't use here. Okay, we use it but we really don't need that for now. That is when we do, like when we access the RDBM is kind of data, right? So then we use it, and then this kind of things are there. So you can there is an SQL utility in Pandas, so where you can pass in exact SQL statement that we have, and you can concat, inner join, merge data set based on those principles. Okay, based on those based on the query outputs, you can merge and inner join those. So that's how this kind of thing works on. So there is another thing. So these are not really used. Okay, joining data frames are not used, or you always will be concating only. Concating or merging things, you will do that only. Okay, so that's how it works. So that is what is about this concatenation thing. We have another thing, that is merge. Now see this will work as a exact SQL join. This thing will work as a exact SQL join. Okay, so how it will work, it is not concatenating, it is merging the data set. See what is the error here? Key error A, right? Why key error A? Because it tried to join this two data set with column name A, but in the second data set we don't have A, so that's why it threw the error. So what I did, I renamed this column to A. Now I'm coming and I am merging it. See, it works, right? Now if you match it, it is the same output as you do in SQL join. If you do create those two tables in DB, if you check the output, now it will match. So concatenation will give you the result that will look the same as SQL1, but it won't be similar as SQL joins. Merge will give you the output that looks like the SQL joins, and it will be the same thing as I mean, it will be working similarly how the SQL joins work. Okay, I will just quickly write these things, all the different kind of joins that we have. Now if you compare all these outputs, right, you will find it that it looks like, see this concat value, how it looks like the first one, right? Like the first output that we saw. So that's how this outer works. So that's what is the difference between merge and concat. So merge will work similarly as SQL joins work, but concat will give you the output that is based on the principle of those, but it won't work like that. So that depends on the scenario. If you are working with this like that database, RDBMS kind of database, then you can go for merge. Otherwise, you can go for concat. So it depends on your need and your scenario, how you are using it. Okay, so that depends entirely depends on the scenario. So that's how it works. Okay, so see here, this when you are wanting to join two things, where you want the common values only, you don't want the entire thing, then you go for merge. If you want the entire value or not only the common values, go for concat. Okay, so that's how it works. So here you need to decide based on the scenario that you have. So that's how the SQL joins work. So if you do a inner join, then wherever it gets a matching value, it will take those into account. So if you see 1 2 2 3 3 4 3 1 4 9 5 10, and then we are joining on column A, right? How we are joining? We are joining on inner join strategy. So which value of A is matching in both these columns? 3, right? So what will be the output? 3, 4, and 1, right? So if you see the output, what is that? 3, 4, and 1, right? So that's how inner join works. Inner join will compare the values of two columns, and wherever it matches the value, it will take those columns from both the tables, those values from both the tables. So that's how inner join works in SQL, and that's why the output is 3, 4, and 1. Okay, so next part, what we will do, we will see all this thing coming into life. So till now, I was showing you some fake data. I was just taking something out of my mind and I was showing you. So what we will do now, we will see how the real data works. Okay, we will read a CSV file that we have. First, I will show you about the file, how the file looks like and all. Then I will show you what all things we are doing with it. What all things we are doing with it. We will see data cleansing. Then we will see the analyzing the basic stats. How can we take out the basic stats out of a pandas data frame? So this is some kind of a cars data set. You can have it from net also. If you are not getting it, you can have it from net also. So this is a cars data set. Okay, you just type empty cars, you will get this CSV file out of it. Okay, so in this cars dataset, as you see, we have a few columns, right? We have 13, 14 columns, and in that we have serial number. The next one is blank, it is not named, so it doesn't have any name. Then we have MPG, SIL, DESP, HP, DRAT, WT, QSEC, PS, AM, gear, and carb. Let's see what those mean. So MPG means miles per gallon, right? So that is the mileage of your car. Cylinder is number of cylinders that your engine has. Displacement is again the displacement of the car, that is of disp. HP is gross horsepower. DRAT is rear axle ratio. Okay, so in the rear tire, the axle ratio. W2 is weight of the car. QSEC is 1/4 mile per time. So that is what is, I mean, for 1 mile, the quarter of a mile, how fast your car travels, that is QSEC. VS is engine, V-shaped or straight. AM is transmission, automatic or manual. So for 0, it's automatic. For 1, it's manual. Gear is number of forward gears. Carburetor is number of carburetors. So that's how this data set looks like, and this is the data dictionary for that. So you can easily get this from net. So that's how it works. So that's how the data set looks like. Okay, now what we will do, we will read this file and we will do some kind of cleansing and all. So before that, let me show you in Excel only what kind of values do we have. We have all proper values in serial number. We have all the names. We don't have any nulls. MPG also the pretty same thing. It's good. MPG also, cylinder also is there. Displacement also is fine. Horsepower doesn't have it also. Okay. So it is fine. Okay, for QSEC, see, we have a few blanks. For QSEC, we have some blank values. Others, it will mostly have some values. So 3 rows, we have blank here. Okay, so we will see how we can, what we do with this 3 rows and what all we do with it. Okay, so let's go ahead and let's jump into the code. So closing out this data set and see here what we are doing. We are reading a CSV file. So for reading a CSV, we have this command of read CSV. Okay, for reading a Excel in pandas, we have a command of read Excel. So if you do it like this, then file name, then sheet name, it will be reading that Excel file with the name. So the format will be XLS or XLSX. Okay, so that's how it will work. So you need to pass in a file name and sheet name. If you don't pass the sheet name, the by default the first sheet will be read into account. For document, what is that? The doc file you mean? Doc file, you won't be getting that kind of data, right? So when you are analyzing some kind of data in here, so that will be in tabular format. That's what is the basic requirement of pandas, right? So we covered this in the first part only, and in data that will be text mining. That's the whole separate thing. So for pandas, the only fit in thing will be tabular data. So we covered this earlier only, right? What is the scope of it? Okay. So see now what is the output here? Only the column for which name was not mentioned. Pandas has renamed it by its own, on its own to unnamed :1. Okay, others are fine. Now if you see this data set, our first task will be to rename this data. Okay, so this is just to show you how you can change the data type. Okay, so you can it's an optional step. You don't need to do this. This is just to show you how to convert a data type. Okay, so for mpg we are converting it to string. So how we are doing, we are writing cards.mpg equals cards.mpg.s type, within bracket we can give anything. So here if you see mpg seems like float values, so we can't convert it to int. If we do it, we will lose the information. So we are converting it to string, so that is not required. This is optional. This is just to show you how it can be done. Now we will see some few analytics functions. So type cards you already know, this is a data frame. Okay, next is how do we see first 5 rows of a data frame? We use cards.head. So head will by default return first 5 rows of a data frame. If we want to have first 10 rows, then we need to pass in the number into the head function. So 10, 12, 20, 30, 50, whatever you do, it will return those rows from the top of the data set. If you want those many rows from the bottom, then you need to use tell function. Tell will work as similarly as head. It will just start from beginning or from the bottom. Okay, so that's what the difference is. Others will work as same. So tell will return you by default bottom 5 rows. If you mention a number within the tell function, it will return you those many number of rows from bottom. Okay, so that's how cards.tell works. Now to check the shape, same thing, cards.shape, as we have seen in the list and numpy arrays. So this shape object will give you the number of rows and number of columns. So see here, it's a really small data set with 32 rows and 13 columns. Okay, that is how you can take out a shape. Now how do we print how many objects are there in the columns actually? So here see, we are doing cars.info. That means if you run it now, you will see the only non-null object counts that are there. It will be printed over there. Okay, so those will be printed in there. Okay, so all these columns will be printed like how many non-null values are there. So see, only the qsec column doesn't have 32 non-null values. It has, that means it has 3 blank rows. We already cross-checked this using from the Excel only, right? Shape is for returning shape and reshape is for changing the shape, right? So that's what the difference between them. They are whole different functions, shape and reshape. Anyways, no comparison can be done between those actually. So for the info, we will see how many non-null values are there. So this is the first point you need to hit as a data scientist. Okay, others that I have shown, just know that those can be done. Those can be done in that way. Okay, you can see first 5 rows using head, last 5 rows using tail, like that. If you need to see more than 5 rows, then you can mention the number from either from the top, then head. If not from the bottom, then tail. But as a data scientist, your job begins now. So you need to check if any of the columns have any missing values or not. So that's where this cards.info thing will come handy. Okay, so here see in qsec we have 3 null values. So your first thing you need to remember is you will need to replace the 3 null values of qsec. How we do it, we'll show it to you. Next, a few basic functions like to find out mean, median, and other basic stats, standard deviation, cars, minimum value of car, maximum value of car, and the count, how many non-null values are there. Next is count of non-null records. This is also another thing where you can see that. Okay, where you can see that. So that is here, if you see the QSEC column value, then it will be 29 only, right? It will be 29 only. So this is another point where from where you can understand like how many non-null values are in there. Okay, so that's how you can do it. Next is how to get all this information stacked in together. So this is cars.describe. So that is the data frame name dot describe. What it will do for you is it will sum up all the stats that we have seen till now in a single place. Okay, so for if you check the output carefully, it has count, mean, standard deviation, mean, max, and all those kind of values, right? All those kinds of values it will print you it will be printed over here, so that you can get all this information at a single place. Okay, so the function for that is car.describe. So that's how it works. Okay, that's how this function will work for you. Okay, that's how this function will work. Okay, next is cleaning. Okay, so cleaning, as I told you, like this one column is there in the data set which doesn't have a proper value, right? Which doesn't have a proper column name. So for that, what is happening? For that, we are renaming the column. So see, now we are doing cards.rename, then we are passing in the same way that we did in the earlier example. So we are checking in we are getting the cards.rename function, then we are what we are doing, we are passing the columns dictionary which will contain the old name and the new name of the of the row of the columns that we want to rename, right? So that's how we are renaming the unnamed one column to model, because if you see carefully, that information that is there is model name on, right? So that's why we are renaming the column with the name of model. Okay, so we are changing the level of the unnamed column to model. So that was the name. Okay, next is filling in missile values. So which column had null values? As we know, QSEC column had null values. So we are filling the null values using fill na function, and what we are filling with? We are filling with QSEC.mean, right? We are filling it with QSEC.mean. Okay, so that's how we are filling in null values. Now after filling the null values, if you check the data set, it will be fine. It won't have those extra, it won't have those null values in place. Now next is dropping unnecessary columns. So you can understand the first one that we have, the first column, that is serial number. So what is it? The serial number is nothing but a straightforward EP series actually, right? So it is just having some numbers from 0 to 32. So when you do a data science related thing, this kind of data won't help you, because what you will get from the serial number, it doesn't have any pattern, right? It is just a EP series. So you can safely remove it, because for data science you won't need it, right? So that's why we have removed the column using cards.drop. So in these columns, as you can see, it is a list. You can have more than one column name also. Okay. For here, we are using only one column name to remove, that is S number, the serial number. But you can use more than one column name in the column list also. Okay. In the list, you can pass more than one values to remove those. That's how you drop the column. So now the column, the serial number column is removed, and we are left with 12 other rows. Let's see what we do with this 12 rows. Okay. Now next thing is correlation. Okay. Correlation in statistics means how do we like get, how two columns are mutually related. Okay, how two columns are mutually related with each other. It is the dependency between two columns, that is what is correlation. So how you can do, you can specify the column names among which you need to find the correlation. Okay, so here we want to see correlation of one column to all the other columns that is present in the data set. So that's why we have passed in all the names. Okay, all the names within the second bracket. So that is basically slicing, right? That is slicing. We have passed in a list of columns inside the data frame. So it will provide you all the values of the columns, and it will calculate the correlation using the CORR function. Okay, so we no need to find out, but it will find it on its own with you using with this CORR function. So that is basically correlation function. Okay, now next what it will do, if you see the output carefully, the diagonal elements are all one, right? The diagonal elements are all one because the name of the columns are matching. MPG, MPG, cell, cell, desp, desp, HP, HP, like that. So here the value will be maximum, right? Correlation between the same column. So MPG and MPG will be maximum. That's obvious, right? So where you have the correlation value generally runs from -1 to +1. So that means if the value suggests if the value is negative, then what that means is the columns are inversely related. If it has a plus value, then it can be thought of as the columns are strongly positively related. Okay. So here if you see miles per gallon and number of cylinders is inversely proportional. Okay. So that means to have high miles per gallon, we should have less number of cylinders. So that is also explainable, right? So that's what happens. So if you have more than one cylinder, then the miles per gallon will reduce because your car will consume more petrol, right? To go the same distance, like that. Okay, so this way you can see all the values are printed. Wherever you see a negative values, that means those are inversely proportional. Wherever you see a positive value, that means they are highly proportional. So for displacement and cylinder, see, there is a high correlation. Okay, for HP and cylinder, there is a high correlation. So positive and high is strong correlation. Okay, that's how you can use this correlation matrix. So what kind of thing it will give you? So if you have any data set and you want to check how many, if there is any relation between two features or not. Let's say let's go to a real world example. Let's say we are going to predict the housing value. Okay, so we have square feet of area, we have garden space. So higher garden space means the price will be higher, right? But if you have some unnecessary column in there, let's say we have a column called this is something which is not necessary to calculate the price. What can be? Let's say main road facing or not will be a factor. This will be a factor. Let's say, okay, any obstacles are there or not outside the house. Yeah, wall paint is there or not? Wall paint is not. So if wall painting is there, that means the price will higher. So let's say if the values, I mean, let's say if there are any obstacles surrounding the place, so this kind of things, those are unnecessary things. Yeah, gate size, right? Gate size is a good one, Anmesh. So let's say if the gate size is bigger, then the price will go high, but that doesn't mean, right, I won't go there. If someone is charging me for their society gate, I won't go there, right? So those kind of things you can remove from there. Okay, if you have zero correlation or very small correlation, then you can remove those. So very small means in the terms of double zeros. Okay, 0.00 then something, you can remove that. So if it's less than 5%, you can remove it. That's safe to estimate, but you can remove it otherwise also. You can remove those from the equation. There are a whole lot of scenarios that we will discuss when we go for machine learning. Okay, so that's where you can use this correlation matrix. Next is we are again here changing the null counts to float. This is just we have converted before to string. That's why. Otherwise it is same. So here also we have changed the QSEC. We have filled in the QSEC, right? So the QSEC column that we have is now having 32 non-null values. That means all the columns that were passed in, I mean all the columns that are there have exactly the same number of values. So that means that part is removed. Okay, that part is by now removed. And QSEC has all the required kind of values. Okay, so that's what is can be seen from there. This is a repetition. Okay, next is manipulation. So in manipulation, what we will do, we will see how to access the data. This is almost the same thing as we do in list and numpy array. So I will just quickly go through it. The only new thing you will see here is iloc. Iloc is nothing but indexed location. Okay, so as you know, we can access the columns of a data frame using names also. So if you use iloc, then the indices that you pass in will need to be only integers, strictly integers. Okay, but this is not really used. What we use is this one. So that's how this iloc is used. Okay, so all these things will be integers. And then if you when I tell integers, it will be applied to all the like those indexing and slicing techniques that we have seen till now. Okay, so that is what iloc. So if you check the outputs here, 6 colon 4 colon, that means from 6th row onwards, and 4 colon means 4th column onwards. So like that it will match. So iloc is the same thing as what we have in indexed arrays. This is same as indexing and slicing of an array, right? Of a list or a numpy array. So next is slicing by label. So here you see we are passing the labels. So that's how we use it. So we want all the rows for mpg column. Okay, so we want all the rows. We want first six rows for mpg column. Okay, so this is again the same thing, slicing and indexing. So that's very much sums it up. So it is the same thing, you can see. So mpg to qsec, we want all the columns and the sixth row on, and for the first six rows only. So that's how it works. Now next is how can you change the column values. So you can access the columns using this syntax on also. Okay, so you can write the data frame name, then within brackets you can pass the string headers. Okay, so am is am drat wt qsec, you can pass it here and you can access it. So no need to use cards.iloc or loc and like that. So here we are using loc, that's why we are passing in mixed of string and integer. One thing need to be remembered, and for iloc we can only pass the integers, either all the two parts of the indexing for row and column both need to be integer. For loc it can be anything. Okay, and to access a column we can use it with a label only. Okay, we can use it with the column label only. Okay, so here what we are doing, we are changing all the am values to 1, just to show you how to do it. Okay, so we are changing all the values to 1 in here. Now next is often you might need to find some derived columns. Okay, next is applying this lambda function. We ran it, that's why we were getting all the values as 2. So this is applying lambda function. So this is just to get some derived columns. Okay, this is okay. VS is a good example. I will show you. So cars, the bracket, condition I want, cars of VS equals 0. Now it will show you all the values where VS equals 0. It will show all the values where VS equals 0. Okay, so that's how you can use filtering. That's how you can use. If I haven't applied lambda function yet, I will do it now. So this is what is about lambda function. So that means, what this means is we can find out some derived columns also. Let's say we are not keeping the name as am, we are changing it to 2am. Okay, so that's how we can do it. So we can apply any function on the column also to get a new value. So what we are doing lambda x equals x star 2. Then what we are doing, we are doing cars am dot apply function f. So it will double all the values of the am column, and it will be double to 2. Okay, so that's how you can apply lambda function to a data frame object or any column of a data frame, more than one column, or you can find out some derived column also. So see, now we have applied the lambda function to this am column. Am was 2, from 2 to am value was 2, and 2am now contains 4, right? So that's how you can do it. I created a new column named 2am, so it will, I intended that, that's why it got appended, right? Next is sort by values. Okay, so this is how easy is to sort a data frame in pandas. You no need to write a sorting algorithm and all. So cars dot sort underscore values, if you provide by equal to any name you provide, it will be sorted based on that column name. Okay, so here we have provided cylinder, so the column will be sorted based on cylinder, and you see 468, that's how it is sorted. So you need to remember this. Okay, sort values, sort underscore values. That's how you sort a data set. And you can pass the option ascending equal to true or false. By default, it will be ascending. If you make it false, then it will be in descending order. So that's how you sort a value in pandas data frame. Okay, so that's how it works. Okay, next is filter records with more than 6 cylinders. I already covered this, right? So that's how you can do it. So see here, card cell greater than 6. What that does, that returns a true false array. So this will return a true false array. Now let's say I am storing it in a somewhere and I want this. Yeah, so see here, here it is written. So filter, I have created a new function that is called cards of cell greater than 6 that will return this true false array. And when I pass it to cards true and false, so wherever it is true, those rows will be returning. Wherever it is false, it won't be returning. Okay, so that's how this filter thing works. Okay, now you can have multiple options. You can have more than one condition also. So car cylinder greater than 6 and HP greater than 300, like that. You can provide multiple conditions and you can filter the array. So that's how you filter and data frame in Python. Okay, so let's go to this data visualization part. I will just show you how you can plot a few curves. So for visualization, we have many libraries, but we predominantly use two libraries, that is Seaborn and Matplot. So here we will show you what is matplotlib, okay, and how you can use it. So the name is matplotlib of the package. So we have imported the matplotlib.pyplot as PLT, okay. Then we have done it, we have forced it to render the picture in the Jupyter notebook only with the inline function. Then what we have done, we have we have plotted the HP column of the car. How we did that? For that, what we need to do, we need to pass in two x and so to plot a curve using matplotlib, we need to use that plot function, that is plt.plot. In the bracket, we need to provide what should be x-axis, what should be y-axis. We have many parameters in there to pass on. We need to pass in x and y values. So here our y value will be the HP column of the car's data frame that we have. Okay, and x value will be 0 to 32, basically the serial number column. So that's why we have taken in range and x equals range and y1 equals cars HP. Then we have passed in x and y1 to the plt.plot function, and the HP values are printed in a line plot. Okay, so that means for the first row, HP value is somewhere around 120. Okay, for the second row, the HP value is somewhere around 95 or 98, something like that. Okay, like that, this curve can be taken into account. That's how this curve can be thought of. Next one is again another line plot with the displacement. So you can see the displacement values in there similarly to the line plot. Okay, similarly to the line plot for HP curve. Okay, so next one is to merge two curves in the same plot. So what we have done, we have taken two y variables, HP and displacement. We have placed both in there, and see this kind of a beautiful curve is being displayed over here. And this legend is also being added with this plt.legend. So see how we can visualize the data, as we are working with the data set. So it won't complete without showing you this. That's why I'm showing you. Okay, so that's how you can visualize this kind of data sets. Okay, yeah, next one is stack plot. Okay, this one is called a stack plot. This is stack plot or area plot, whatever you can consider. Okay, so this is the same thing basically. This is the area chart or stack plot, any way you can mention it. So see here, it will show you the area covered. I am going to the second example. So it just shows you what is the area covered by the curve. Okay, what is the area covered by the curve. We have two plots here for HP and DISP. So we have two areas covered. So this is stack plot and this is area plot. That's how we plot this. This is to show you the area covered by the curves. Okay, so that's how this works. This is bar chart. This is a very popular chart among IT people. Everyone knows this chart. We use it frequently for presenting our estimates and all and all and all. So this is very popular. So this is how it looks, this bar chart, and for that we use plt.bar, okay, to plot this bar chart. So we are plotting the car models and the car's HP in a plot. So that's how it is. So here the plot, the car model names are there. These are the HP values of the car that are plotted using bars. Here it is using horizontal bar. For that we need to use bar each function. Okay, so that's how it works. So here also model name and HP, model name and HP we are plotting in a horizontal bar. Okay, so that's how you can do it. So that's how basically you can use matplotlib and pandas object hand to hand. Okay, so which of the following will be used to read CSV files? So the which of the following is used to read CSV files? Which one? pd.read underscore CSV, read underscore file, or data frame.read underscore CSV? Which one? So next is what will be the output of the following? So that means that is ARR equals 124578. Small lists are passed. Then DF equal to data frame ARR. Index equals ABC. That means the row names are ABC. Column names are capital A and capital B. So how the array will look like? A, B, C, capital A, capital B, 1, 2, 4, 5, 7, 8, like that. So 3 rows will be there. Okay, 1, 4, 7, 2, 5, 8, and the name of the rows will be A, B, and C. Small ABC. Name of the columns will be capital AB. Now we want to have colon, comma, capital A within quotes, right? So what will be the output? So A is the correct answer because we have passed in the row labels to be ABC, not 0, 1, 2. Okay, what is the output of the following? Okay, see here the march function that we have used. pd.dataframe 1 colon 1 a comma a, and df1 is 1 comma a. Okay, df1 is 1 comma a. Now small a is capital A, small a, capital A, small a. This will I need to type. So basically the output, which one it will be? A will be joined 1a. So here if you see 1 colon 1 and a colon a, 1 means this array 1 1 1, and a means this array a. So the arrays will the first array will look like 1 will be the column header, a will be the column header, 1 1 1 is the value. So this is the first column of the first array. This is the second column of the first array. This will be the second column of the second array, and this is the second column of the second array. Now if you inner join, the middle one will be common and others will be merged. So that is the output. So A is the correct output. Okay, next is import pandas as PD. Data frame 1 equals pd.read underscore CSV, some dataset dot CSV. Now to view first 15 rows, what will be the command? Should be D. Next is to rename a column in given CSV dataset. Which command is used? We need to mention the like argument if it's a column or index, so row or column. So columns we need to specify. So A is the correct answer. Okay, that's what is about pandas. Data visualization, why it is needed, what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture what is data visualization. So data visualization is basically presenting a data, presenting numeric or any kind of data with using using charts and graphs and or any other pictorial formats, right? So by that what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay, also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like see, this is the data that we drill down and this is what we have found out. So this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field, this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time what you will do is you will grab a already defined and already optimized library that is available in net. Those are also, those are all the time will be open sourced. So those open source libraries you can grab and you can use those to use those as it fits your purpose. Okay, so that's what is what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are trying we are going to give a summation like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them like, okay, this is what is the thing. Okay, and we can ask data from clients also, so that's how we can do. Okay, so in those cases, data visualization comes really handy. Okay, and data visualization involves presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have, 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some, till 18 you will have some XYZ kind of data. But that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, right? Like girls are more initiative in this. Or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this. And next is, I mean, data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just, I mean, just plot these data, if you just show them with the picture, like compare the upper table and the below pictures, then later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always always be using this technique to get some insight from the data, like that. Okay. Okay, so now the things that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right? Like some average, standard deviation and all this kind of average basic stats, then you will see that those have almost the similar kind of values, right? Some is always like 99, some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye, like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you will, where you will see how different the data sets are, how different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right, this will look something like this, that is in my screen. So let me just grab my piece of code for this NSCOM portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried. That is, I mean, already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation. It's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only 1 or 2 points are here and there. Those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data, it is stacked. All the points are stacked in here, because if you check this, all the x values for the last one is set as 8 except one. For one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one, for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see, their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this ANASCOM portrait is a unique data set. Okay, this ANASCOM just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this ANASCOM portrait was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with 4 data set, obviously with 4 x and y data sets. So for 4 of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay. So for in here, those 4 of them are, all the 4 of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay, so that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values, with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import matplotlib into our Python code. So matplotlib, why matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this matplotlib code, right? So that's where what we are doing is, in this matplotlib code, what we are doing, we are just I mean, in this is a matplotlib library, and this is a object oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this xy points and you can try plotting these points in the plot, like we showed in the last class, right? How to plot a line chart. So you can try it that way also. If you are not having the data set also, So then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this Anascom quadrate picture won't be given. I think so, because I don't have it. If they have updated, then fine. You can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take two arrays x, y, x1, y1, x2, y2, x3, y3, four arrays you can take of x and y, then merge those. Like for x, y, plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see, the equation will fit this one to some extent. So yeah, that will be better. So if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here, we have used plt.plot x and y1. If you even if you for now, if you don't even I mean, if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now, keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things. No need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done xy1, xy2, xy3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why is that? Because if you see, the x part for all these three data sets are same, right? So only one array would do, and for y we have four different arrays, and we have plotted those. Okay, we have plotted those using this plt.plot line. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, I mean, if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one, it will take the horizontal axis, second one, it will take the vertical axis, so it will have x and y too. Okay, other things we are we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have matplotlib, ggplot, seaborn, plotly, and geoplotlib. So all these plots comes handy in data visualization, but the matplotlib, it has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like, as you saw, right, we have a setup function, we have a access function, text function. Those, all those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is matplotlib is there. Next is seaborn. Seaborn is again built on top of matplotlib, and that's also a very good plotting library. So, but and generally we use matplotlib the most. Then comes the seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay. So let's go ahead and see why matplotlib. I have told you something, but there are some other points also. So this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multidimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that, like the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multidimensional graphs. So 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is this is a next is why to choose matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, I mean sorry, object name dot function name, that's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on numpy, so numpy is also possible. I have shown you examples, but this matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like how what all types of graphs we have in matplotlib and how that can be used, and what are the usage of those graphs and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean that's how easily you can visualize a function in matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is. Next, what we are gonna see is what are the different types of plot that we have. Before that, let me come to this inline thing. So this inline function, if you don't have it, it will still work. Okay, this percentage matplotlib inline, you won't see a difference in Jupyter notebook. Okay, because this Jupyter notebook is anyways browser based, right? So this won't give you any difference when you use matplotlib from any web based or any kind of notebook kind of scenario. Okay, but if we have a different set of, I mean if you are running Python separately, right? If you are running Python separately, correct, using spider, it can be spider, it can be a simple command prompt of Python, anything can be there. So if you are running it from those, IntelliJ idea means PyCharm. Okay, for Python the ID name is PyCharm. So if you are running using those IDs, or if you are running using like what, let's say if you are running it from the command prompt, then this will create a separate window. So that's where it gets difficult. Okay, so that's where it gets it is, I mean, it is advisable to use this like numpy, I mean, sorry, this matplotlib inline command for having the graphs inlined to the screen that you are currently using. Okay, otherwise what it will do, it will create you a whole separate thing. Okay, so it will give you a different set of, I mean, a different window where you will see the plot. So that's why we use this matplotlib inline. So that's the basic standard, to have it displayed in the same window. Okay, so that is why we use matplotlib inline. But if you don't want it, if you want the separate window to pop up, it will also work. Okay, that will also work. So that's no need to be worried. Okay, before that, let me show you what are the different types of plot that we are having in matplotlib, and what are their uses. Okay, then we will go to each of the examples one by one. So if the what you need to remember from this whole lecture will be three things. Okay, first of all, why and what plot need to be used, where it need to be used, and how you can write those. Okay, customization, even if you learn it slowly by playing with it, it's perfectly fine. I don't That's not a matter. Okay, the customization thing, coloring thing, changing the axis labels, adding legends, changing the colors, there can be thousands kind of customization in matplotlib. Okay, so do I have that mail with me? No, I will have it my official email ID. Okay, so what I did, for some requirement I created, there is some kind of graphs and charts that goes to higher management. Okay, for reporting purpose, that goes every day. Okay, so I created something using Python, no data science is involved. That's a straightforward thing, much easier. So I created a simple script or simple job using Python. What it does, it takes in data from a rdbms, it plots the data nicely in a matplotlib plot, and it sends it to you, sends it to the upper management. So when I am telling upper management, that is D plus. Okay, so that's where this comes handy. So and there you understand, right? When we are going to show this to upper managements, we need to have the graphs beautiful, we need to have all the specifications, we need to have pointers, we need to place them in the right position so that they don't find any errors and they won't accept anything so easily, right? So that's how powerful matplotlib library is. I don't have the I can't show you that because that's not allowable. So otherwise I would have shown you. So that's how you can do it. So the graph, what I can do, like the simple graphs that you are seeing in here, you can change the background color of the graph. Okay, so the background will be of some different color and the foreground will be of some different color. As you are seeing there in the right hand side, we have a bar plot, right? In the bar, you can choose each and every bar color one by one. Okay, that can also be done. All these bar objects can be accessed individually. Okay, once you plot these bars in matplotlib, right, all these individual bars can be accessed one by one. You can change their width, you can change their height, you can change their color, you can set text to them, you can write text in between them. So whatever you can do in Excel with all these graphs, the same things can be done in matplotlib. But again, those things are not required for your day-to-day work. It will require me very rarely. So if even if you don't understand those, if you even if you like the NSCOM quartet I have shown you, if I start explaining the whole graph, it will take the entire class because it has too much customization in it. Okay, so just to keep it short and just to give you the proper idea so that you can start experimenting or playing with it, the basics I will tell you. Okay, and on the basic you can build up. Okay, you can build up on the basic. If you do understand the core concept, you can easily build up. So, and also if you are facing any problem, you can tell me in the next class also, I can help you. Okay, so that's how powerful matplotlib is. And let's see what kind of graphs we use. We have line plots. So line plots, what we use just to plot 2D equations, right, with x and y, there we will use line plots. Okay, so line plot will give you a trend line in an equation. Okay, so when we see linear regression, we will see its use pretty heavily, okay, for machine learning, and also for observing a data set how it is distributed. This is really needed. Okay, next is bar plot. This is the same as line plot. The difference between these two is you can add a trend line in bar plot also, so that way it will become this, but this denotes the area covered by the point. Okay, so the bar will start from x-axis and it will go, the height of the bar will equal to its y value, and the shaded area will be showing the area covered by that point. Okay, so that's where bar plot is needed. Bar plot is basically thus it is required in the same way we have line plots. So what is different in here, in line plots you might not be able to tell what is the value of x for the value of y at x equals 17.5. You need to go there, you need to see, it will be difficult for you. But in bar plot you can see it there directly, right, because the bar will do that. Significance of width, there is not much, it is just to illustrate, okay, illustrate this bar one. Okay, this is that is how this bar is designed. So bar means it will show you some area covered by the curve. So if you calculate this rectangle, so what it has, this rectangle is same this rectangle has this width of some x value, height of this y value, right? So if you calculate a rectangle covering that area, so this will denote the area covered by that point. Okay, by that x and y point, from the ending to beginning, this area will be covered. So area is shown here. Next is scatter plot. So scatter plot and line plot again are same, but only difference, the points are not joined. So you need to understand when we use these two. When we have a continuous set of data, we know that it might fit a linear equation, right? It Yes, Azam, I just explained it. What is the significance of the area, right? So in the line plot, if you have like if you have a what like continuous set of data, then in that case this line plot will be visible. But if you don't have a continuous set, if you have some chunk of data, clusters of data, then you will use scatter plot. This is to see the data distribution, how they are distributed, and this is the trend line of the data. This example of scatter plot you will see when we are covering clustering. You can understand, right? We have seen some clustering algorithms. So if you plot the data in this plane, then from that you can easily understand how many clusters will be formed from that k-means, right? The k value you can find it from your you can find it by checking that manually only, right? If you plot the data, it will be clear to you. After clearing the data, if you are able to plot that data in this plot, you can find the value of k without any hack, right? And you can pass it to the algorithm to give you those many clusters and their centroids and all. But what you not need to do is you no need to check the data points and decide which point will be belonging to which cluster. Those things you no need to calculate. Okay, next is this histogram. Histogram is basically used for image processing purpose. This histogram shows you basically, okay, so this histogram is basically used for like image processing purposes. And what this bins are denoting, this bins denotes the number of times the values, the frequency of the values, the frequency of each point occurring in the data set. Okay, so that's what this bins are denoting. So this is not really used in data science, somewhat used, but it won't fit our purpose always. So maximum for image processing this is used to see how the data is spread and what are the frequency of the data point that we have, what are the frequency of pixels that we have, those kind of cases, and histograms comes handy. I will show you all these examples, but again this is not really required. Image plot, again this can yeah, CPU processing is also histogram, right? So that's what. So wherever the scenario fits in, to show you some frequency kind of thing, wherever it fits in, then you can use histogram. Okay, wherever you need to find out some frequency of some point in dataset, Let's say for CPU processing, if you see the graph how it will look, it will give you how much CPU is used in what point of time and what is the frequency of high CPU uses. In that case they will use histogram because it will give you the frequency related data. Okay, difference between bar and histogram is bar plot won't give you this frequency, it will just plot the x and y points. It is almost similar to the trend line except it will show you the area, it won't show you the frequency, but from histogram you can find out the frequency. When we go to example, let's see how we can do that. Okay, okay, next is image plot, right? Image plot is to plot some image. Okay, again you won't need that. So image plot will fit in a existing image to this to the 2D plot, and it will show you the height and width and all those things you can see visually. Okay, next two plots are really important for us, those are box plots and violin plots. Okay, so let's do one thing. Let's see the examples of all the 5 plots that we discussed, then we will discuss the rest 5. Okay, rest 5 or 6 whatever we have, we will discuss those after that. Okay, let's see these examples first. So this line example I have already shown you. Now the next one is how to customize these lines. So basically these are the basic customization technique I will show you. So see here what we have done. We have taken the same example as the earlier one, just we have reduced the number of points. We have used this fig equals plt.figure, fig size equals 10,5. So this one, this plt.figure object, what it does, so if you don't use it, that also work, but how it works is this plane is a single plot. Within the plot you can create multiple figures. So let's say you want to create two charts side by side. In that case you will use this figure. Okay, you will create a figure size, I mean you will create this 2D plane first. Okay, then you will plot this line. That is the best standard practice, so you should follow that. Okay, you will create a figure object, then you will plot the data points. Okay, that is the standard that we do. So how do we do that? What we do, we use plt.plot function as shown before. We are having x and y, two values for x and y data points. Next we are passing is this line width parameter, right? So this is to provide that line width, what it will be. Next is line style. It has many different line styles also. It has dash, you can give 0, you can give o, any character you can give. Let's say I am giving I, and if I run it, it won't run because I is not a supported character. What was that supported one? I don't remember. I think dash was supported. Yeah, so this line style you can provide anything. Okay, sorry, not line style. Line style will be dot dash, these two things only, or a continuous line. I was talking about this marker. Marker you can put anything. Okay, so marker you can put something like this also. Unrecognized marker. Marker, except to what we had cross, I believe. We had cross, yeah, we have plus, those kind of markers are there. So this marker object is to show you this points. Okay, show you this data points, how you want to see those, but o gives you the best visualization among all. Okay, so that's how you can use it. Okay, next is this line style is for styling these lines, this intermediate lines. If you provide colon, then it will be like this dashed line. If you provide a dash, dashes will join, right? So dashes will join, and you will see a straight line. So that's how this works. Next is color. You can provide any color. You can write the full name also. You can use the short name also. You can provide here the RGB values. You can provide. Let me show you. You can provide this hex values also. You can do anything. Okay, let me take the default color that is coming. So I will show you this to example. Come on. Okay, if I tell it take it this, and if I put it here, this will also work. Okay, see that lines have changed to blue, right? If I provide this, that will also work. I don't remember the syntax for RGB. RGB is not much used, but still, okay, sorry. But still you can provide like this, I believe, and RGB like this. No, RGB is not the thing. RGBA, how was it? How was it? I don't remember. Okay, RGB styling in Matplotlib. Just let me check it. Check in Google. I will show you. Just a second. RGB, anyways, we don't use it much. We use the simple names or hex codes, because hex codes you can find in many places. Like like in net, you can have it easily available. You can create your own colors. But RGB we really don't use in plot. Yeah, so that's how. So I will still show you because it can be done. So I believe we can only mention the tuple. We no need to write anything in behind. Let's see. Still it doesn't work. Why? How to give it? Just the tuple without this single quotes? I believe yes. Let's see how it works. Still not working. Okay, how do I give it? How do I give it? Why it is not working? Not sure. It should work like this. Somewhere it is not working somehow. Not sure. I will check in the break and I will tell you. Okay, this one I will tell you. So you can provide the hex value or you can provide the mnemonics also. You can type in any color in full also. If I type it yellow, it will also work. Okay, so that's how you can use this color attribute for all the graphs. For all the graphs you can use it. Okay, so you can type in any color or you can provide the hex codes also. Okay, so let me give some good color here. So that's how it works. Okay, that's how this color attribute works. Next is for alpha. Okay, alpha is for reducing the brightness. Okay, reducing the I mean the transparency of it. Let me give it blue. That would look the best. So that's how. So alpha is the transparency. Okay, alpha is the transparency of it. Yeah, that is not working, Nancy. I also remembered the same thing. RGB is not working. RGB, nothing is working. So I will check and tell you, no issues. Okay, next is alpha is for reducing the brightness. So let's say you will understand on your own only. I no need to explain. If I run it to 1, see this is much vivid. But if I do it 0.1, you will see this is way too dim. It will be way too dim, right? So that is what is alpha. Alpha is for reducing the brightness. So alpha is the transparency factor. So if you reduce the alpha, then what it will do, it will make the line or plot whatever you are doing transparent to the plane. So it will match the background color of it. Almost it will match the background color of it. It will be a very fade color. But if you pick a high alpha value, it will give you somewhat deep lines. Okay, you will see the dark lines, dark colors over there. Okay, so that's what is alpha used. Marker, as I have shown, these points are called markers. So that's how we plot a line. Next is this title object, right? This title function. So what we do with this title, we plot this title like line plot demo. This we put it using this plt.title and it will automatically be placed here. Okay, it will automatically be placed at the top. You can change it to bottom also. You have options for that. But the basic that we follow, the standard, that is to put it in top always. And x level, y level, x axis, y axis, you can type it. So the labels, axis will be labels. Okay, axis will are labels. It is not for the value, it is for the labels only. Okay, that's how it is. And for the limit of it, the graph will take on its own. It is best to leave it on its own because it will be helpful. Because if you are trying to manipulate the graph, because see, you will always not know this, right, that how much data you are covering, how much data you are taking, like that. So that's why this is best to leave it on the graph itself. So it will decide the best min x min y, min x min y, and max x max y, and it will plot it. Okay, so that's how it works. Okay, next is for plotting legends. Legends means this small markers. So to show you, to show someone which one line denotes what, right? That is what is legend. So for plotting legend, what we do, we use this legend function. Okay, we use this legend function, then within bracket we line the marker name. It can be a list also. Okay, it can be a list. If we had two lines here, let me show you. That will also work. Let's say I have an orange object now with marker as cross. Okay, and it is darker. Let's make it darker. And if I run now, you see we have two lines now in the same plot, right? So how you can have here, you can write like this, and see everything will be taken care automatically. Okay, see here in legend it's already added, the my line thing is already added, and else equals base means the graph will on its own calculate the best position for the legend and it will put it. So it will always put in the best position. It can be down, it can be up, it can be anywhere. Okay, plt.grid true, that is to show these grid lines. If you don't want it, just don't mention this function, it won't show you these grids. Okay, so that's up to you. If you like the grids, you can keep it. If you don't, you cannot. So there is no really no real thing in that, in showing or not showing the grids. Okay, somewhere if you fill it, you can provide you can have those displayed. Okay, so that's how this grid works. And plt.show, as you know, to show the plot, to show the to, I mean to display the plot in front. So that's how this thing works, this line plot works. Okay, okay, so that is what is about line plot. And you have seen only single line plot in a picture, right? So I have shown you two line plots in the same graph, right? Let's say we have two different plots in the same we have two different subplots in the same plot object. How do we do it? Okay, so that is where this subplot function comes into picture. That is where this subplot function comes into picture. So if you see carefully what we have done here, we have taken the same thing, the same functions that we used in the earlier example, and we have shown you this we have shown here the two different plots in the same thing. Okay, we have shown two different plots in the same figure. So that's how. Okay, so the next thing is the parameters that we have passed and how do we create this subplot. Okay, so how do we do is, firstly what we did, we used plt dot subplot function. Okay, so subplot function, we have, there are many parameters that can be passed on to it. Okay, there can be many parameter. So we have provided only three parameters here. This is just to have it in a standard one. Okay, so how does it work? Okay, that means the first one, 2, right? These are for number of rows and number of columns. Okay, so we have created one number of row and two number of columns. Why one number of row? Because we want this to have in a single subplot, right? We want this to have in a single plot. So see, when I change it in two rows, so this first one gets smaller, right? Because it has created two rows. First one contains the first graph, second one contains the extra portion of the second graph. So always try to have n rows as one if you don't want to create more rows. Okay, so sorry, for the first subplot, for this first subplot, if you create two rows, then the same area will be divided into two parts. So the graph became smaller in and got fit into one row, and the next row is left around. Okay, so that's how it is created two rows here. So here, so the idea is, if you want to fit two graphs in the same subplot, then only go for this 2 1. Okay, but standard is to use one, because we generally, when we subplot it, we want the subplots to contain one graph. If you want to fit in two graphs like this, you can create a separate subplot here, and you can plot the graphs. Okay, so that's how this plt dot subplot is used. See here we have passed in number of rows and number of where we have passed in only plt dot subplot, we have passed in some integer numbers. plt dot subplot 221 222, so these are just integer numbers, right? So this is 221, this is 222, the starting point of the subplot, and the plot will adjust on its own. This is also an expression that we use, but this is not standard. Okay, this is not standard. This is just to have four plots, four plots arranged in a rectangular way. The standard is always this one. So we pass the number of rows, number of columns that we want, and this one is for number. So that means how many figures are there. Okay, how many figures are there. So this thing, the pyplot.figure function that I have shown you in the in the earlier part, that will be called, and the figure number will be attached to it. That means this is figure number 1 and this is figure number 2. Okay, so if you want to customize it using this figure object, then you will see how you can use it, but that is not really required. Okay, for now just know that this is a number parameter that is being passed into this function, and that denotes how many number of what is the figure number that is there in the graph. Okay, so for the next one, if you see, we have created the same subplot size 1 2, and we have provided number equals 2, so that means this is a figure 2. So this is figure 1, this is figure 2. Okay, the rest function the same as what we had in this. So plt dot title, it has plotted these titles of graph 1 and graph 2. Plt dot show showed you the graph, and plt dot plot plotted this x and y1 and x and y2, these two things. Okay, so that's how now line plots can be created and customized, and also multiple line plots can be created in the same subplot. So this applies to all the other graphs that we are going to see. So we won't show you those in that much detail, but you can always create a subplot. You can fit in two bar plots, two line plots, two scatter plots, anything you want in there. Okay, so
number of columns means like one on x-axis and one on y-axis, or what? How?
no, number of columns will denote the width of it. Okay, the height and width, these two things. So if I give it one, it is so small that it just went out. So that means if you want to divide this, right, how many columns you want in the figure. Okay, so so we want two graphs to be displayed, so that's why we set it 2. If we do it 3, that means we have a provision for the third graph to be displayed, and see, this graph is smaller, right? So if you change it to 3, it will be smaller, because it is providing you option for creating a third graph here. So the entire figure, how many columns are there, so that's how it denotes. Okay, so that's how it denotes. So if you do it one, only one graph will be displayed. Okay, so that's how it works. Okay, so that's how you can create this subplots. So is this clear? Then we can move on to this bar plot. Okay, so bar plot is basically to show you some counts, to show you some this is basically used to show you counts. Okay, so see here what we have done. We have created a data set with three this is a dictionary, right? So we have count for apple, mangoes, lemons and oranges. Okay, for x-axis we have taken the dictionary, the list of keys from the dictionary, and for the y-axis we have taken the list of values, that is the count for those. Again, we have created a figure size. How do we plot a bar chart? We plot a bar chart using plt.bar. We passed in x and y. This kind of nice little rectangles are shown over here. So this is 15 and this is the area behind this curve. So next we will see how can we change the width and all of this curve. Okay, so let's go to this one. See here, this is actually this like horizontal bar graph. Okay, so here for horizontal bar graph, we have taken the same data set, we have used bar each function, right? So bar each and bar both will have the same kind of customization. This width will be decided on its own, you no need to specify that. Again, as I told, you can change it, height and width you can change, but that is way too advanced. Take your time, you can work on those things later only. Okay, so this can be done. Just you, if someone asks in the interview, just tell them yes, we can customize those, it is not by default. But how that is a really advanced topic. I don't think interviewers will know also. Okay, next is data. How do we create horizontal bar chart? This is a reverse bar chart. So here we can have bar each function to be called for the plot, and similarly we pass in the arguments. Now the next thing to be covered is like bar and bar chart customization will be same as both will be same. So here beside this I can provide the colors also. Okay, so colors, let me put, say what should I put? Let's say I put maroon. So next one I will make it green. So that's how it looks. Okay, so you can pass in the color object, color parameter to it, and these bars will be colored according to that. Okay, so similarly for bar and bar each, same things will be applied. And this plt dot title, x level, y level, we have already seen, right, when we covered this line plot. So similarly those can be plotted. So see here, bar graph demo, quantity, fruits. Here also you can put it in the similar way. You can put it in this way. Let me show you. Copy is not enabled file. So the similarly you can do for bar and bar each. So remember, bar is for plotting bar, bar each for plotting horizontal bars. Okay, so that's how bar plot looks like. Okay, so that's how bar plot looks like. Now next, any doubts in this, or scatter plot is fine now? So now we will go to the scatter plot. Okay, so scatter plot, see, scatter plot is a bit different. It is not like x and y equation. So we have three data sets, a, b and x. So this is x and y equation actually. So for this x value, this is y value for one. So let's consider this as x and y, and consider this as x and y1. Okay, so no equation we need to do. What we can do, we can just generally point these things. Okay, we can just distribute the points over the plot. Okay, so that's how we did. Okay, and this points will be taken automatically. Okay, the colors will be taken automatically. So next we will see how can we customize it. Okay, these are the basic customization techniques, not advanced. Many things can be done with it, just remember that. Okay, so again I will change it tomorrow. Okay, so here, okay, next thing to be show you is for line plot we use plt.plot, right? For scatter plot we use plt.scatter. We pass the x and y arguments inside this scatter, and then we get this nice looking output. Okay, next is customizing scatter plot. Same equations we have taken. So this c, either you can write c or you can write color, anyway it fits you. Okay, s is for size. That means size of these things. If you make it, let me add another 0 and run it. So it will bigger the size of the data points that you have. So size, that is really size, you can write a whole or you can mention the short name, anyways it will work. Okay, age colors means if you see these lines carefully, the age is colored as yellow. Okay, because so age is colored as yellow. So for, if I do it black, you will see that, I believe it is really hard to see here. If I make it 1, I think you can see. Yeah, now see, the green round objects are covered by a black border, right? So that is the age colors to differentiate between 1 and 2. Marker, it can be different kind of things. So marker have 0, o 1 if we give, it will give you some this kind of downwards value. 2 if you give, it will give you some upper kind of values. For 3 you will have the in the reverse side. Okay, in the reverse arrow. And 4 you already have it, right? Or if you put o, it will be the round objects that is going to be put. Marker, can we customize? No, we cannot. Okay, so these are the choices for the marker object. Alpha, as we discussed earlier, alpha is for the same thing. Okay, alpha is for the same thing, to reduce the brightness of it. Okay, next is plt.legend, title, x level, y level, same as others. Plt.grid, same as others. So now if you see, we have a plt.savefig, scatterplot.png. So this is to save the output of the curve. That we discussed earlier, right? This is to save the output of it. So if I go back to my Jupyter notebook, see here, scatterplot.png is saved. And if you open this graph picture, you can see, and then you can use it for your own purpose. You can attach it in mail, you can send it, or you're going to do whatever with this. Okay, so that's how you can save the figure to a nice looking image. So that the command for this is savefig, plt.savefig. Okay, so plt.savefig, that's how it works. So that's what is with scatter plot. And now next is this histogram. Okay, so is that clear? Next is histogram. So histogram is to show you counts for some numbers. So we have taken a huge data set to show you this counts. Okay, and we have created the histogram using plt.hist function. Okay, next we have passed in the array that we need to plot in histogram, and we have passed in this bins, right? So bins means where these markers will be put in. This is again intuitional, you can put it anywhere you like. So these are the markers, the marker points. So 0, 20, 40, 60, 80, 100, like that we have given. So how to, yeah, bins are intervals only, correct. So how to understand this histogram? So can you check the data? If you check the data set and if you see how many points are there between 0 and 20, 1, 2, 3, 4, 5, 6, 6, right? So if you check this, so 20 we have 1, leave it. So till until 20 we have 5 points, right? If you check from 0 to 20, what is the value? What is the y value? 5, right? For 20, so from 20 to 40, if you count, we will have 7 values, so it will be going up to 7. Okay, 40 to 60, it is really small, right? Only 1. So see here, the height of histogram shows you 1, right? 60 to 80, if you count most of the numbers, so 68, 64, 62, 60, 70, 78, 75, 79, and all those numbers. So almost 7 numbers, 7 numbers almost. So if you check, or 8 numbers, whatever, so you will see 8. Okay, 80 to 100, 3. So 3. That's how to understand histograms. Okay, that's how you need to understand histograms. So that's what histogram denotes. Histogram denotes the frequency of data points between a range. So from 0 to 20, how many? 22. So what happens if we add another bin, right? The graph shape will change radically. Why that will change? Because within 0 and 10 we don't have any point, so it has kept it blank, so we haven't put the marker over there. Now let's say we are plotting a marker in 30. Okay, we are changing this to 30. So see it, from 20 to 30 the bin has changed, right? Because we have created two different markers. So 20 to 30 we have a dip, right? We have a dip. So within 20 and 30 we have 3 points, and 30 and 40 we have 4 points, like that. So that's why between 20 and 40 we have total number of 7 points. Okay, that's how to understand this bins attribute, and that's how to explain a histogram to someone. Yes, right, it will be changing with data, correct. Okay, so this is to color the histogram. We, yeah, so that's what I'm telling, right? So that's what I told earlier only, right? Before starting with the examples, bar you will see when you just need to, when you have the counts of some data points, you need to display those in a graph. So that's why you, when you use bar, linear equations, when fits into scenario, you use line. When you want to see the distribution of data over a plane, you use scatter. And when for image processing kind of thing, and when you need to find out counts of data points, you use histogram, right? You don't know the counts, you want to find out without writing a code, you can, if you plot a histogram, you will have the count. So that I told when I covered the theory part of it, right? Okay, next is customizing histograms. Again, we have provided this bin numbers. Age color we have provided as black, and color we have provided this funky red color. Okay, title, X level, Y level, grid, savefig, already you know this, right? So same thing, not wasting much of a time. So age color and color, we can do it in all the graphs, and we can customize the graphs. Okay, so that's how this works. That's how this histogram works. Okay. Okay, so that's what we discussed till now. Image plot is not really required. We are not so for now I am skipping it. It's not really required. do I have it? No, I don't have it. So any images can be plotted into it. Okay, so that much you can remember. So that will be enough for you. Okay, so that's how it is. Okay, so that's what we have till now. So next we will discover box plots and violin plots. So let's have a 20 minutes break and come back. We have a lot of theories in mind. So then we will discuss this. Okay. So box plots and violin plots are hugely used. I will tell you when and where to use it. So any doubts till this bar plot, or is it okay? We can go for a break and then come back and go for this box plot. Is this fine till now? No questions? Then we can break here.
So one question, like each plot has its own significance, right? Exactly, we have to, for a linear we have to use a line plot kind of things, right?
Correct. Right.
Histogram we have to use in one place, and bar, where exactly we are going to use bar and all?
When you have the counts defined, you use bar. When you don't have the count, you use histogram. Okay. See, this
And
is just to this is why we are using data visualization. Again, have the concept clear. This is nothing but showing a I mean showing the data in a graphical way, right? So if you tell this data to the clients, it will be hard for them to understand, and for you also, you would need to read this carefully and all, because in real world data set only you have already seen 300 rows, right? But in real world data set you will have 1 lakh of 1 lakh or 2 lakh rows of data. That will be pretty much on the cards. Okay. And me and you don't have the infrastructure to run that, so we are limiting to small examples. So in that case, when you are going to find out all these insights by manually checking, it will be impossible. So that's why this plots. So you need to understand the scenario and you need to apply it. Okay, so that's how. So let's get started. So if you see this box plot, right, box plot contains the quartile information of a data set. Okay, this is the statistical plot that we use heavily. So this below line will be your Q0 and the top line will be Q4. In between, this will be your mean, that is Q2. This will be Q1. This will be Q3. Okay, 4 lines will be there. Now this is how this data will look like. Now how do we calculate those Q1 Q2s? Okay, I have considered this data set and I have calculated all those calculations. I have done all those calculations in my Word doc. Okay, in Word doc we have all these calculations. So what we are doing, we are just having the equation. We are just sorting the array. So if you sort the array that is given, you will get this kind of an array. Okay, this array you will get this one. Okay. So next, what we are doing, what we are doing is we are finding out the second quarter. We are finding out the mean of this. So how do we find out mean? What are the number of points? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So we have even number of points. What is the definition of mean? Mean is the middle point of the data set to which all the left values will be less than to that mean, and in the right side we will have greater than or equal to the mean, right? So we have taken, and for odd even number of values we take the middle two values. So we have taken these two values, we found out their average and we found 20, and 20 is our mean. Okay, 20 is our mean, and this 20 is referred to as second quartile also. Okay, now so this is the mean. Okay, so here we split the data set. Okay, here in this 20 point we split the data set. Now as we have two middle points of the data, so 2 point we can consider in the for two parts. First let us take this part. Okay, let us take part from this to this 20 and part from this to this 20. Let us take this two part. Now this is already sorted, so we will again calculate their mean. So here if you see 5 number of data points are there, so that means odd number of data. So we will have the midpoint, that is 10 as our quartile. So 10 as our mean. So this mean is called as Q1. Okay, this is the first quartile. Okay, from 20 to 70 we have 30. This is called Q3, third quartile. So what this does, this gives you this three Q1, Q2, Q3 informations. And if you see Q0, Q0 is the minimum number and Q4 is the maximum number. Okay, Q4 is the maximum number. These two are first and fourth quartiles. Okay, so 0th can we say 0? So that is our first quartile. second, third, fourth, and fifth quartile. So we have 5 quartiles. So we generally consider this for Q0 to Q3. Q4 is the last one, so we don't really consider this as a quartile, but you can tell it like that. So this information will be pasted in the box plot. Okay, this information will be provided in the box plot that we have in here. Okay, that we have in here. So if you see carefully, for the first, this total, this is the box plot for that. What was the minimum value? 1, correct? So here is, it is 1. What was the first quartile? 10. What was the mean? 20. What was the third quartile? 30. And this sums it up. Okay, this 30 sums it up. So this is the box plot. This much you focus on, and the max point, that is what I was referring to as Q4, that is not there. That doesn't present. That is not present anyways. So here it is. Okay, how this height is defined? From 10 to 30, how many points are there? 6 points. So that's why this box is a bit bigger. Okay, that box is a bit bigger. So this, the height of is it's almost 6. So that is what this height denotes. Okay, from 10 to 30, how many values, like that. Okay, so that's what is this height about. Okay, that's what is this height about, or you can say it like Q1 and Q3, in between this height is given. Okay, so this box means here the maximum number of data point are concentrated in here. So between 10 and 20, how many points are there? If you check, so we have 2 10s and 3 20s. So in a data set of 10, we have 5 values within 10 to 20, right? Within 10 to 20. So that kind of information you can get from there. Okay, that you can get from this box plot. So it basically shows you again the distribution of the data and the basic statistics of the data, the quartile range, and how and where and which part of the data is concentrated. Where the data is more concentrated. Okay, the height of the box is how many points are there, like that. So 10 to 20 or 10 to 30, we have 7 8 data points, so the box is a bit bigger, like that. And from 0 to 10, we have 3 data, so that is the height. Okay, it won't match with the graph. It is just for visualization purpose. It won't match with the graph height. I am just telling you for ease of your understanding. Correct, that is IQR actually. So IQR is, this is between Q0 Q1, this is between Q1 Q2, this is between Q2 Q3. Okay, so that is what is the frequency of the data, right? So that's why we calculate IQR. IQR is to give you a rough idea about how the data is, what is the frequency of the data, how it is spread in a in a range, right? So that's how this works. This won't match with the box line. So this big lines are IQR, interquartile range, and how many data sets are there, like that. So that's what is about this box plot. So here we haven't done many things. We have taken 3 distinct lists. We have taken all those into a single list, and we have plotted the data sets, and we have plotted that using box plot. Okay, that is the command for that. We have told it to show the means. We have passed in that show means to be true, so that's why that orange dots are shown. Okay, those are the means actually. So that's how this box plot works, and that's what kind of information you get from this box plot. Okay, that's what kind of information you get from the box plot. So this is what is about this box plot. Others I have already explained, so not repeating those things. And if you go on this code perspective, we have taken 3 different lists of total, order, and discount, and we have combined all those 3 lists into one using this list command, and we have passed 3 separate lists to plot it. This is just to have the information handy, because this is just to follow the syntax of the box plot, because it takes in the entire data set and it will create 3 boxes for 3 different data sets that it has. Okay, so that's how this box plot works, and that's what kind of information we do have from this box plot. And generally speaking, when you start analyzing data, you will use this box plot to quite some time. Okay, to check the data distribution and to check the quartile range, to check how it is distributed among the quartiles, and like that. Okay, okay, so that's what it is. Okay, see, don't think about the height much. So that height is basically the IQR, that is the distance between Q0 Q1 and that shows how many data points can be there. Okay, so that's what is this height reflects. Okay, height doesn't have much of an scenario here. So this is just to connect the plot and show it like a box. That's why the heights are there. And the distance between two quartiles are called IQR, that is interquartile ranges. Okay, so the height, the value of the height is interquartile range. So the I mean that is the frequency of the data set. Okay, what does that mean? So say 0 is the minimum value and 10 is the first quartile. So if you check the quartile range for the first quartile, that is 10, right? So the height equals 10. Okay, the mean is 20 and the Q3 is 30. So what is the that quartile? That is like 10, right? So that's how this height is there. That is the interquartile range actually. Okay, so that's how it works.
And 70 is outliner. It will exclude that while calculating.
No, it has calculated that, but that is the max value, so that's why it has kept it that far. Okay, that is the max value. But for quartile calculation, we don't take into account the max value. Okay, so that's why it is left out. That is a max value, right? We don't take it into account like that.
So why we don't take into the account? Because it's far away or something like that.
No, because that is what the value of because that is how we calculate the quartiles, and that is what is the IQs are all about. Okay, we don't take the last one. We have only 4 quartiles, Q0 to Q3. Q4 is not taken into account, so that is the max value basically. So that is not taken into account. That is not outlier. That is how stats work.
Okay, okay.
Okay, so any questions? Okay, so next one is violin plot. It is the same as this box plot, but it is different. It has the same values. Okay, Q0, Q1, Q2, mean, and all those kind of things. It has, but what you see here is a violin kind of a shape for all this distribution, right? So that shape that you see, the shaded area that you see outside the middle line, that is the probability density function of the data set. Okay, that is the probability density function of the data set. What does that mean? Okay, what does that mean? So okay, what does that mean? This shaded area. Okay, this shaded area. So this is the probability density function. That means probability of having a number between. So what is probability density function? Probability density function means the probability of a point being in a range or a probability of an event being occurring, right? So let's say we have a range of 0 to 10. What is the probability that in for a particular data set, what is the probability that number 4 will occur? What is the probability of number 4 will be there in the data set? That is what probability density function calculates. Okay, so that means this is the probability of an event being happening in a sample space. You can if I go by the by default stats terms, that is how it looks like, probability of some event happening in a sample space. So that is what it defines in probability density function, and the same thing reflects in violin plot. So how can you use it? Similarly, as I show you the calculation for Q1, Q2, Q0 to Q3, same lines are there. See, only 4 lines will be in here, right? If you see, there are 4 lines, so those lines are for Q0 to Q4, like that. And then the outside shade is the probability density function. So how can you see, what can you configure from those? Between 1 and 20, how many values are there? If you check the data set carefully, there are 5 to 6 values between 1 and 20. So that's why the curve is thickest at that point, right? So there is a high chance that if any future data comes in, so it will be in that range. So basically you need to think it in a bit other ways. So this static data set won't explain you. So let's say you have built a model. Okay, you have built a model based on some features. Okay, what is model and all, don't go too deep. Model is an algorithm. Okay, that we will discuss in the next class. So how I mean, I am trying to explain when you use it and how you use it. So let's say you have built a model without seeing anything. You have put in some features. You have taken into you have assigned the features into the weight to the features. So now how do you validate that? So if some feature values are in between, lying heavily between 0 and 20 or 30, then that means when you get a test data set from that of the same pattern, it will always follow that probability density function. So that way you can understand which feature to have what kind of a weight. Okay, so and which feature is having what kind of a distribution. So these things you can check. So that won't be only a single feature, that will apply for all the features. That is a machine learning data set that you will have. So this applies to all those. For ease of understanding, I explained with one, because there is only single arrays are taken into account. So this we will plot for all the features, and we will see how the data is being differing. Okay, what is the probability that in future we can have different set of data. So if we have some true false kind of skewed data set, we will have it often. So 0 and 1 kind of data set if we have, then probability density function will have two peaks, one near 0, one near 1. Okay, so that's how it will look like. So let me try and show you. 10 points we have, right? 4, 5, 6, 7, 8, 9, 10. See here, because this is not visible, because this is having this large values. So this value, if you enlarge it, you will see that this is stacked between 0 and 1 only, right? So you will see two peaks in here between 0 and 1. So that's how this thing works. So let me try this. See, you have two peaks, right, between 0 and 1. So as we have more ones, so the peak is flattened near 1. As we have less number of 0, so it is flattened near 0. But see, between 0 and 1, the curve is getting shortened, and when it goes so 0.6 will be their mean. Okay, because that is what we have taken as 0 and 1. Okay, so 0.6 will be their mean. And if you see from 0 to 0.6, that the curve is let's say 0 to 0.4, the curve is wide enough, right? Because till 0.5 we can consider it to be 0. So from zero point 0.4 onwards it started to increase, because if it is greater than 0.5 we can estimate it as 1, right? So and at the 1 it has a maximum width, and at 0 it has a maximum width. Others are just shortened, right? So that's how probability distribution function you can use. So here what you can see, this is a skewed data set, right? This is a skewed data set. So this cannot fit a straight line equation or something like that. So you need to change it. You need to change the thinking, and you need to choose, explore other options. So that's how you can check that. Yes, this is a binomial function. So this is a skewed function. It will be of form e to the power x, right? E to the power x by 1 plus e to the power x. That is sigmoid function. Like that we will have this. Okay, this function will output two values only, 0 and 1. So that's how it works. Okay, so that's how violin plot works. So if this is clear, we will just I don't have examples for this because we won't need that. I will just explain these three plots actually. We won't need that much, so I will explain what are those and how they are used, like that. Okay, next is this quiver and stream plot and area plot. These three we are not gonna use much. I will start with area plot. What is area plot? Area plot will show you the area covered in a line. So how you can see that? You can check like this. So let's say we have a line plot. Okay, we have a line plot. I am drawing some line over here. So let's say we have a line plot like this. So let's say this is the line plot. So area plot, what it will show this area. So it will show this area that we have inside this. Okay, that is the area plot. So that is to show you the area covered by a curve. Okay, area covered by some curve that we have. So that is what is called area plot. Okay, that is what is called area plot. Now if I show you here, like this is the quiver plot, right? So if you see all these individual data points, right, these individual data points are looking like vectors. It has some directions, right? So that is for basically magnetic field analytics and high-end physics needs. These are basically vectors. These are basically directed vectors. This is basically needed by physicians. Okay, this is basically needed by physicians. These two plots, this stream plot, this one up here, and this one down here, these two things are basically required by physicists to analyze the vector and to do vector analysis. Here if you see, this has pointed ends, right? So that is the direction of the vectors that goes in or out. So electrical engineers or physicists can use this plot. So if an electrical engineer is there in class, you will understand this, right? Current inflow, outflow, and all those kind of stuff. So if you have a large circuit, it will something look like this, right? So if you have a midpoint in here, what is the current input, what is the current output, and all those blah blah stuffs of electrical things will be there. So that's how this quiver plots are used. That's how the stream plots are used also. In stream plots, what is the stream plot? What is the difference? The difference is in the stream plot, we won't have that vector direction. We will just have positive or negative value for a vector, and that will be just a representation of the vectors in a 2D plane. Okay, so that's how this quiver and stream plot works. An area plot shows you the area covered under a curve. So these three plots, data scientists are rarely uses. Even if you use area plot somewhere, some down the line, but quiver and stream, let me assure you, you won't use it ever. Okay, because we are not gonna deal with vectors, right? That's how. Okay, so any questions on these three plots? So before that, I will just quickly go through these points. I have told you, but still, see here, where is bar plot used? So bar chart or graph chart is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values they represent, right? That's what. So the bars can be plotted vertically or horizontally. So what is categorical data? When you have counts, count kind of thing. When you have some categorical data means where we have categories defined, right? So here apple, oranges, and all those kind of stuff, and related to their counts or their price or their anything. So these type of data are called categorical data. So then we do use bar plot. Okay, for scatter plot, where is it? Yeah, scatter plots are used to plot data points on a horizontal and vertical axis in attempt to show how much one variable is affected by another. That is, what is the distribution of the data set, right? What is the distribution of the data points in a 2D plane, right? How the data are distributed. So if the data are very closely stacked, that means x and y values are very closely related. So we will have a high correlation. If they are widespread, then we will have a low correlation, right? Because they will be independent. If you see very high what sorry, so if you have a very high difference between two data points, so that means if the difference is more, that means the correlation is low, and they are independent kind of thing, right? Because in those two, if x and y has a pattern, then they will be following a pattern, right? Either they will be clustered, either they will be having a linear equation like that. Okay, so that's what it helps you to understand. And in a cluster, all the values will be tightly correlated. So if you try and find out a cluster here, you will see 1, then 2, then 3, then 4 clusters, right? Like that. So you will see 4 clusters are there, so they are not tightly coupled. But if you see in a cluster, this 3 or 4 data set, they are almost following a line, right? These two are following a line. So that kind of values you can get from scatter plot. I have told this, but it is written beautifully here. So that's why just covering it. The sentencing are good here. That's why. Okay, histogram I explained. So plot used to display frequency across a continuous or discrete variable that I already discussed, right? Box and violin also viewing summary statistics, and is an efficient way. Also box plot helps you in doing outlier analysis. So these are outliers, right? This is the outlier because you see the quartile range finishes here, and some value is up way there. So these are outliers, right? These are the max values. These are way far high than outlier than the Q3. So that means almost all the data sets lies between this, but this data lies far above that. So this is an outlier, right? That's why it is left out. That's why it is left out. And if it is not an outlier, it will be close to the line, right? If the value is not an outlier, it will be close to the line. So that way we will see. But again, that won't be plotted using dot, because the max will be plotted using dot here. Let's say we have a value of 35, so it will be somewhere around here. So that we can't consider as outlier, right? Because it is pretty close to the Q3 range, right? So that is there. That value is there. So that's how we can use box plot. While in also same thing, except that we will have a probability distribution function attached to it. Okay, so that's how we have image plot. Let's leave it. Let's not let's not go into a bit detail. So just know how to do that. If you open a image, okay, so how you can do it, you have image processing library called pillow inside Python. Okay, you have pillow library in Python. You can install it. No need to do it. Okay, no need to do it or remember it. This won't be used. So using pillow library, you can use this image function, and you can open an image. All images are what? Arrays, right? They are arrays of pixels. So you can convert it to a numpy array. You can pass that numpy, you can plot that numpy array itself, and that would serve your purpose, right? That will serve your purpose. So this is what ax1.imshow. Imshow is for showing the image. That is again a pyplotlib matplotlib function. And if you pass in the array, the corresponding values will be shown as a image here. Okay, the corresponding values of the pixels will be shown as an image in the output plot. Okay, so that's what is image plot. And the image plot to histogram also you can do, so that way you will see the distribution of the like that distribution of the colors in that, right? Colors or pixels in that. So see here, this is at 250. This is a very high value, so it might be some pixel having high value, because see, blue is having a pretty dominant color here. Blue is pretty dominant, right? So that's why it might be causing this high value kind of thing, right? So that's how is for image plot. That is not at all used. Quiver scheme, as I already told, the example is not much required. See here, this is a plotting a vector. How can you do? You can do it using quiver, this quiver option. Okay, this quiver option, we have created a subplot, then we have created this quiver option. Okay, using this quiver, if you pass x position, y position, and the directions, so you know, right, the vectors will have two directions, 1 0 1 minus 1. This is the direction of the vector. So it will go from 0 to 1 upwards, and this will go from 1 to minus 1, that is in a downward way. So that's how the vector directions work, and that's how the vector calculations work. That's how you can plot a vector. Okay, you're using quiver plot. So this is a 2D plot. This is a stream plot actually. So stream plot is used for vector calculation, vector algebra, vector physics. I mean, wherever you have a vector involved in physics, electromagnetics, electrical engineering, stream analysis like cyclone analysis, wind trend prediction, like those kind of scenarios, you will have the stream plots into account. Okay, so this is just a bit different from the vector plot. And here also you have the same thing, the stream plot function. Okay, but you won't be, you will use it pretty less. Okay, see here, this is a trend analysis, a wind trend analysis kind of thing. Okay, so that's how this stream plot works. So see, the pie chart is to show you percentage or proportional data. Okay, so this can be this can come handy when you have more than 4 or 5 categories. Then box plot will take up a lot of space, and from the box plots also you will only see the values, right? The counts and the categorical values like that, but you won't see the percentage of the data that is being placed in those each of the categories. So those kind of scenarios, pie plot comes into picture. Okay, I will show you the coding example for this pie chart. Okay, but it's not much left for pie chart to be customized. So let's see. So if you see, so now it will be easier for you to understand all these functions. So first, what we have done, we have taken a label array of 4 and size array of 4. So that denotes in a data set what are the number of dog, cats, wolves, and lions that we have. Okay, so if I show you a quick math, that then it will be easier. So let's say what are the values that we have? We have 50, 45, 60 and 80, right? We have 50, 45, 60, 80. So how it calculates? So 50, 45, 60 and 80. So it comes to 140, it comes to 95, this two comes to 275, right? So we have total of 275. Now if you calculate 50 by 275, how much it comes? It comes to 10 by 52. So that is somewhere around 20%, right? If you calculate this, it is somewhere around 20 or 19%, right? 50 is the count of dog. What is the percentage of dog? Percentage of dog is 21.3%, right? So this kind of percentages are calculated and shown over here. Okay, for cat it is 45, so it will be around 90% like that. Okay, so that's what kind of information you can get from this pie chart. Okay, now how do you plot that pie chart? You need to use plt.py function. Within py, if you provide some, and the options I will explain now. So sizes is one variable, labels is another variable. So labels we need to pass it, because otherwise this labels of lion, dog, cat will won't be shown. So and it will be equally, it need to be in the same order as the size array. Okay, otherwise the this labels will be misplaced. Okay, next is auto pct percentage 1.1 f percentage. That means what is the display percentage, what will be the format of it. So we want only one decimal after we want only 1 point after the decimal, right? So that's why we have given 1.1. So that is the number will be whole intact, then after the decimal we want only 1 point. So that's why 1.1. Shadow true means you see there is a shadow effect inside. If you give it as false, I will show you, then you will understand the difference between these two, shadow true and false. So if it's a if it's a 3D plot, I mean, if so here the shadow is not really visible, but it should be if you use lighter colors. Okay, lighter colors will have you the shadow visible, so it will have a bulging effect actually. So that's how it will look. So that is not much used, you can leave it. Okay, start angle is 90, means then the angle will be 90-degree angled. Okay, so it will have a equal kind of a shape, so it will have a equal kind of a array actually, I mean sorry, equal kind of a shape of the circle. So that's why start angle equals 90. Explode, as you can see, if you mention 0.1 as an explode, then it will be those slices will be cut out from the array and it will be outside the array. So that's how explode function works. And explode you need to give one for each. So where I have mentioned 0.1, those slices, see, they're cut out from the pie chart, right? That's how this pie chart works. Okay, so pie and donut, I will finish it, then I will open for question here. So donut chart is the same thing, just the difference is it shows the area. Instead of showing the percentage, it shows the area. Okay, for that what we do, we create two pie charts and we combine those. Okay, so see here, we create one pie chart here. This pie chart, if I show you one by one, so this is a pie chart, right? We don't have the numbers mentioned, so we haven't mentioned auto PCT, so it haven't shown. We haven't mentioned shadow, so this kind of effect is not there. If you see these two, a difference between these two, you will understand what is the difference of the shadow function, right? So this is a pie chart. Okay, we have created a pie chart using this variable that we have. And okay, this is color white, let me make it black. Black is coming as blue. Why? Okay, black, only one body takes, that's why it's taken blue. Okay, got it. So that's how it will take only one word in the color, so that's why it is taken as black. If I put O is not supported. Y is supported. Okay, so Y for yellow. So you see here we have a yellow kind of a circle. So this circle is to give the blank inner filling. Now if I run this first pie and second pie together, see this effect we want to give, right? So this is a pie chart that is there. So if you remove this second pie chart, what happens? This is the entire chart, correct? This is the entire chart, correct? What is the radius of this? 1.5, right? Now we want to show it as a donut. So what we can do, we can cut out some area, right? So that without saying, if I draw it, it will be easier. So being said that, so let's say this is a bigger circle. Okay, let me change the color. So let's say we have blue here. So this is a bigger circle and we have these three parts. Okay, we have these three parts. Okay, let me change the color again. Let's say I'm taking green. So this part is green. So next I'm changing it. This part is pink. Let's say like that. Okay, and this part is orange. This is filled up. Okay, this is entirely filled up. I am not going to fill it up. So what you can do, you want to show only this much. Let's say only this much you want to show. Oops, sorry. Let me change the pen color. It will be easier for you to understand. I have exhausted all the colors. No. Let me show. Let me just think. We want to show to the viewer this much of value, this much of portion. So what can we do? We can fill it up with some value. We can fill it up with some color. Let's say we are filling this up with orange. Okay, what will happen? This shade will left upon, right? This outer side circle will be left upon. So that's what that's how you can create a donut chart. It is not an option in it. So let's say if I increase this, you will see the donut chart gets shrinked. Okay, the donut chart will get shrink. That's why we have used white here, and that's how it works. Okay, if you use 1.5, the donut chart will vanish and it will have a slight effect over there, right? If you use 1.3, it will be pretty thin, right? So that's how you can create a donut chart in matplotlib. Okay, that's how you can create a donut chart in matplotlib. The pie chart you will create and you will empty its center. That's how you can create it. Okay, so two pie charts combined together will give you a donut chart. Okay, so that's how this works. Okay, so for your ease of understanding, I will leave it as yellow only, so that it's better for you to understand how you create donut chart. There is no donut chart. You are fooling the audience. Okay, so next is area chart. So area area chart I have already shown in the last class, right? So what you can do, you can use stack plot function, and if you pass two variables, then it will show you the variable the plot covered. So let me show you using a line equation. Okay. Oops, sorry. Let me copy the line equation that we had earlier. Which one? L. Yeah. So that's how this will work. Okay, that's how this will work. So for this color, if you write black, it won't work, but if you do color, it will work. Yeah, so that's how it works. Okay, so see, now we have, let's not give it green, let's give it maroon, let's give it green. So if you increase the transparency, it will be easier for you to show. Yeah, looks nice. So that's how this stack plot works. So see, this is basically denotes the area covered between a curve. Okay, a curve or a straight line or whatever is it. Okay, so that's how this stack plot works. So stack plot is basically for showing you the area. Okay, the area of the plot covered. Okay, so that is how we have this area plot. So this area plot you might use somewhere, but not much used at all. But this quiver and stream you won't use. Pie donut you will use often. If you have some presentations, you will use this. And without from now on, what I can suggest you, if you are working on some data on Excel and generating some graph on Excel, try to switch to this one, right? Try to switch to this editor like this, like Python. Okay, so just try to switch to Python, and then you will have nice looking charts, nice looking things, and you will learn this matplotlib library in a vast details. So that will help you. I believe whoever is there, everyone is working on this Excel heavily, so you can try it. Okay, You can try Python for generating those charts also. So that way you will learn it. Okay, you will learn it quite well. So that's how we have. So that is what we have theory portion for this charts and all. Okay, so that's how we have. So if nothing, then let's go for the quiz. So let's go through this quiz quickly. I believe you will have a 10 minutes early day off and you can enjoy the rest of your Sunday night, whatever is left. Okay, I already got the answer for this and it is correct. This is bar H. So if anyone is differing from the answer, you can tell. Okay, if anyone thinks it is different, you can tell. You must have something missed. I will explain once more. We are plotting a line plot between two variables a and b to add a legend, which will be the following option we need to use. Which one? Can anyone give it a try? Yes, that is C. No, that is not the syntax, Anvesh. We pass the location in the same array only, so it will be C. Okay, let me cross check also. Yes, right. You are right, Anvesh. It is B. Sorry for the confusion. It is B. So we pass the location as a separate argument, not in the same one. So it should be B. Okay. So it should be B, not C. So it is wrong here. I will have it corrected. Let me add a note. Okay, let's go for the next one. To add title, which one is the option? Which one is it? Right. Okay, which of the following represents categorical data? Area, histogram, quiver, bar. Nice. You guys are fast. Correct. It's bar plot. For categorical data, we have bar. Which of the following is useful to display data with 10 categories? Histogram, bar, pie chart, area. Repetition, it should be B, right? Bar.
So I'll start this session by giving you a brief introduction of PySpark. We'll discuss things like what is PySpark, why PySpark, what are its various advantages, and once we are done with it, I'll show you how some of the big tech giants in the market are using PySpark in their development. Now by then, since you guys would have a fair idea of what exactly the PySpark is, so I'd move forward to the installation part, where I'll teach you to install PySpark on your machine. Well, if you want to get the most out of this tutorial, I'd suggest that make sure that you're performing the demo side by side. This way we can have an interactive session and you can post down your doubts in the comment section below. And we'll try to reply them at the earliest. So once we are done with the installation, we'll finally end this session with the Spark fundamentals, where we'll discuss about the Spark config, the Spark context, Spark files, RDDs and data frames in depth. Don't worry, I'll make sure that I take some relevant demo which will give you a better idea of these topics. I hope the agenda is clear to you guys. Shall we move forward? Okay. So let's start with our very first topic, Introduction to PySpark. You know what? The average salary of an Apache Spark developer is around $110,000 per annum. So there's no doubt that Spark is used in industry a lot. Now when it comes to Python, because of its rich library set, it is used by majority of data scientists and analytics experts today. So combining both the Python and Spark was a major gift to the community. Spark was developed in Scala language, which is much like Java. It compiles the program into bytecode for the JVM for Spark Big Data Processing. So to support Spark with Python, the Apache Spark community released PySpark. So guys, what do you think a PySpark is? Any rough idea, anyone? Okay, fine. I'm assuming that you guys know that it is something which has to deal with both Python as well as the Spark, right? Since I already told you that Python is an open source, powerful, high level and object oriented programming language, and yes, in terms of its syntax, it's way easier to use and read when compared to other programming language. On the other hand, the Apache Spark is an open source, general purpose distributed computing engine which is used for processing and dealing with large amount of data. So here comes the PySpark. It's a collaboration of Apache Spark and Python. It is an API for Spark which easily integrate and work with RDD using the library called Py4j. So let me tell you, PySpark is an API where you merge the simplicity of Python with the power of Apache Spark in order to tame the big data. For those of you who are already familiar with Spark and the concept of RDDs, for you guys, you can think of it as a Python API for Spark which easily integrate and work with RDD using a library called Py4j. This PySpark, it offers a PySpark shell, which links the Python API to the Spark core and initializes the Spark context. I hope by now you guys have a brief idea of what is PySpark. Alright. So let's move ahead and let me tell you about some of its advantages. This will help you to know more about why you should use PySpark. So like we can see here, we have speed, powerful caching, real-time computation, deployment, and polyglot. So on number one, we have speed. So when you compare it with the traditional large-scale data processing, it's definitely 100x faster than them. Alright. In terms of powerful caching, well, PySpark will give you a powerful caching with disk persistence capabilities. On third, we have real-time computation. Well, there's a plethora of data which need to be processed in real time. Let me tell you a fact. You know what? Every minute, around 48 hours of video is being uploaded on YouTube. Twitter gets around 98,000 of tweets and more than 168 millions of emails are sent every single minute. Well, these data comes in bits and pieces from many different sources. It can come in various forms like words, images, numbers, and so on. So Twitter is a very good example of words being generated in real time. We also have websites where statistics like number of visitors, page views, and so on are being generated in real time. There's so much data and they're not useful in their raw form. We have to process it and extract insight from it so that it becomes more useful to us, right? So this is where Spark Streaming comes into picture. It is exceptionally good at processing real-time data and is highly scalable. It can process enormous amount of data in real time without skipping a beat. Alright. Next feature we can see over here is deployment. Well, you can deploy PySpark through Mesos, Hadoop, or even through Spark's own cluster. Alright. Next we have is polyglot. Well, simply it means that it supports multiple languages like R, Python, Java, and Scala. It basically provides the shell and Scala and Python, which you can access through the bin folder of both Scala as well as the Python. Alright. A question might arise in your mind, like under which situation should I use Python? Or under what scenario should I go with Scala or Java or R? Alright. So let me tell you a fact. The most used programming language with Spark are Python and Scala. Alright. So now if you are going to learn PySpark in this tutorial, it is important that you should know why and when to use Spark with Python instead of Spark with Scala. So let me just compare Python and Spark with some parameters. This will make things clear for you to decide. So our first parameter is performance speed. Python is comparatively slower than Scala when used with Spark, but programmers can do much more with Python than Scala because of its easy interface that it provides. On the other hand, Spark is written in Scala, so it integrates very well with Scala, making it faster than Python. Alright, so next we have is the learning curve. Python is known for its easy syntax, and being a high-level language, it makes it easier to learn. Whereas Scala has an arcane syntax which makes it hard to learn, but once you get a hold of it, you'll see that it has its own benefit. Alright, next is the data science library. Python supports multi-data science and machine learning libraries. But on the other hand, Scala lacks proper data science library and tool. Scala does not have proper local tools and visualizations. Alright. Finally, the last parameter is complexity. So Python API has a simple yet easy and comprehensive interface. Whereas on the other hand, Scala's syntax and the fact that it produces the verbose output is why it is considered a complex language. I hope the things are getting clear to you. So before we dive deeper into the PySpark concept, let me tell you about how big tech giants like Yahoo, TripAdvisor, Alibaba, and other big multinationals are using PySpark for them. Well, Yahoo uses Apache Spark for its machine learning capabilities to personalize its news and web pages, and also for targeting advertisement. And also for target advertising. They use Spark with Python to find out what kind of news users are interested in reading and categorizing the news story to find out What kind of user would be interested in reading each category of news? Next is the TripAdvisor. Well, TripAdvisor uses Apache Spark to provide advice to millions of travelers by comparing hundreds of websites to find the best hotel price for its customer. The time taken to read and process the reviews of the hotel in a readable format is done with the help of Apache Spark. Alright, let's discuss about Alibaba. Well, Alibaba, I guess most of you have heard about it, right? It is one of the world's largest e-commerce platform and runs some of the largest Apache Spark jobs in the world in order to analyze hundreds of petabytes of data on its e-commerce platform. Alright, so I guess now you have an idea that how PySpark is being used in the industry, right? So before I continue, has anyone any doubt up till here? If yes, please add it over to the comment section below and we'll try to reply them at the earliest. So guys, if you're a mobile viewer, get ready with your laptop because now we'll proceed with the installation part. So let's install PySpark in your system. Just to keep it real, just in case you are stuck, you'll find many installation reference out there on the internet, which you can just go ahead and refer to and get installed. So guys, in this tutorial, I'll be teaching you how you can install PySpark on your Windows machine. Alright, if you're a Linux user, add your email ID below and I'll send you the installation step for it. You can just follow it and install it on your machine. Fine. Well, before we actually proceed with the installation part, there are some prerequisites required for PySpark installation that you must know. So as a part of prerequisite, you must have the Jupyter Notebook installed on your machine and you must have an updated version of Java. Alright, so let's just open google.com and just search for download PySpark. Well, I'm assuming that you guys have installed the prerequisite for this session. So proceeding ahead, let's download the Spark. Just Google it, download Spark. The very first link which you'll get is the Apache Spark link. Just click over there and it will redirect you to the Spark Apache website. As you can see over here, the Spark release is 2.4 of November. It's very recent. And the package type which I'm selecting is pre-built for Apache Hadoop 2.7 and later. You have other options available over here. So I'm selecting pre-built for Apache Hadoop 2.7 and later. And finally what I'll do, I'll just click over the download link over here. It will redirect me to a different page where I can see over here it's a mirrored link for me. I'll just click it and my download will start. I think it's a pretty big file. So yeah, it might. So yeah, it's a pretty big file. Just make sure that you have a very good internet connection if you are downloading it. For now, I'll cancel this as I have already downloaded this file. So let's cancel it. Let me just show you where I have downloaded it. And the downloads, I have this file. Spark 2.4 Ben Hadoop 2.7. Alright. Just unzip it. Extract files. I'll extract. Just extract the files. The files I extracted, I'll just save it somewhere. Like, let's save it in the D. Okay. By the time it does save it, just open your CMD. So our next step would be to edit our environment variable. So let's create some environment variable using the setx command. My first variable is spark underscore home. And after that, I'll specify the path of my Spark file. So this is the path. Let's paste it. Done. Okay. Next, I need another environment variable as Hadoop underscore home. Then again, specify the path of the file. Hit enter. Done. Now since I want to launch my PySpark shell in Jupyter Notebook, so I need to define two more parameters over here. PySpark driver Python and PySpark driver Python OPTS. Alright, this will help me to open the PySpark shell in Jupyter Notebook. So I'll write setx PySpark underscore driver underscore Python and IPython. Hit enter, done. And my next parameter is setx PySpark underscore driver underscore Python underscore OPTS and notebook. Hit enter. It's done. Alright, let's close this terminal. Now let's open a new command line prompt. Now my first task would be to redirect to this bin folder. Alright, so this is the path. Let's copy it. Jump to the D directory. CD space, I want to go over till bin. So yeah, so this is my path. Hit enter. I'm in bin. Now my next step would be to execute PySpark with the command PySpark. I'll use a master parameter for setting the master node. And since I want 2 cores for local testing, so I'll specify master local. How many cores? I need 2 and hit enter. So what it will do, it will open me a Jupyter Notebook on my local host. So yes, we have successfully installed PySpark on our machine. If you are facing any issues, comment it below with the error message which you got, and I'll try to resolve it for you. Okay. So for now, just click on new, select Python 3, and it will open a tab where you can write your PySpark code. Alright. So this is the Jupyter Notebook with Python 3 where I'll be writing my PySpark codes. Alright. So now is the time that we start and learn with the fundamentals of PySpark. So now the installation is complete, so I guess we should proceed with the fundamentals of PySpark. So as a part of PySpark fundamentals, so we have Spark context, Spark conf, Spark file, RDDs, data frame and MLlib. So I'll start with Spark context. Well, it is an entry gate for any Spark derived application or functionality. Let's see in detail what exactly it is. So when we run any Spark application, a driver program starts, which has a main function, and your Spark context gets initiated here. The driver program then runs the operation inside the executors on worker nodes. Now this PySpark, it uses Py4j. This Py4j enables the Python program running in a Python interpreter to dynamically access Java object in a Java virtual machine and create Java Spark context. By default, PySpark has Spark context available as SC. So creating a new Spark context won't work over here. Alright. Let's move ahead. So here are some of the parameters related to Spark context. We have master, app name, Spark home, serializer, gateway, con, PyFiles, environment, JSC, profiler CLS, batch size. Among all of these, only master and app name are the one which are used most frequently. So for this tutorial, we'll focus on just 2 of them. The master represents the URL of the cluster it connects to, whereas the app name is nothing but the name of your job. Let me show you this with an example. Let's open our Jupyter Notebook. So let's write our very first PySpark code. From PySpark, import PySpark context. Alright. And next we'll define a SC as Spark context. And inside this, my first parameter would be the URL. My URL is local. And my next parameter is the name of my application. I'll name it as anything like my app. So I guess we are getting an error like cannot run multiple Spark context at once. Alright, so you can resolve it just by writing sc.stop. Okay, hit enter and let's reload it again, execute it once more. Yeah, so as you can see here, my error is gone and the statement is executed. Alright, so what I did over here, I defined the URL and the app name. Now this parameter, it cannot be changed throughout the program. Alright, so alright, this was all about Spark context. So moving on ahead, let's see another PySpark fundamental. So on the PySpark fundamental list, next we have is this Spark conf. Well, it is used to provide a configuration to run Spark application on local machine or cluster. So what exactly is Spark conf? Well, to run a Spark application on a local or a cluster, you'll have to set few configuration and parameters. And this is where Spark conf comes into picture. It provides the configuration to run a Spark application. Initially what we do, we create a Spark conf object with Spark CONF function, which will load the values from Spark. Now you can set different parameters using the Spark conf object, and once you set the parameter, 30 minutes, half an hour. Initially, we'll create a Spark conf object with Spark CONF, which will load the initial values from Spark. And once set, their parameters will take their priority over the system properties. Alright? Remember, once we pass the Spark configuration object to Apache Spark, it cannot be modified by any user. Thus, it becomes immutable. So we have set, set master, set app name, get, set Spark home. Alright. So set, it is used to set the configuration property. You specify two parameters over here, key and a value. Fine. In set master, you specify the master URL. In set app name, you set an application name. Finally, there is a get. Get is used to get the configuration value of the key. And finally, there is a set Spark home, which is used to set this Spark installation path. Let me show you this with an example. This should make things easier for you to understand. Alright, so let's move ahead. Alright, so let's jump to our Jupyter notebook. So let's define our configuration file. For this, I'll use from PySpark .conf import Spark configuration. Alright. Next is from PySpark.context import Spark context. Alright. Next, what I'll do, I'll define a variable as conf, and in it, I'll define my Spark configuration function. Dot, I'll set the app name as set app name, name of my app. I'll name it as PySpark demo app. And I'll set the master as local 2. Fine. Now let me show you how this get function is working. So since I defined this CUNF variable, so I'll just write over there CUNF.get. Inside that value, my value is what? Spark.master. Spark.master. So what it will do, it will give me the master URL which I have already set. Fine. Let's hit enter. As you can see, we got the URL as local2. Fine. Since I have already set my master URL as local2. Now what if I want to check my app name? So configuration.get spark.app.name and hit enter. So my Spark application name was PySpark demo app. Alright. Fine. Alright, so I guess we can move ahead. So next in the PySpark fundamental we have is this Spark file. The Spark file, it helps in resolving the path of files added to Spark. Alright, so what exactly is this Spark file? Let me first tell you what it is. So whenever you have to upload your file in Apache Spark, you can upload it using the sc.add file, where sc is your default Spark context, remember? Right. And whenever you want to retrieve the path on a worker, you can get it using the sparkfiles.get. The Spark files is used to resolve the path of the file added through Spark context.add file. Okay. Now let's talk about its class method. Spark file contains two types of class method, get and get root directory. Get is used to get the path of that file that is added through the Spark context.add file, and get root directory function is used to get the path of the root directory added through sc.add file. Fine. Let me make things more clearer with a demo. Alright, so let's check out the demo for Spark files. So from PySpark, import Spark files. Fine. Next, from PySpark, I want to import Spark context. Next, what I'll do, I'll define my path. Path equal os.path.join, and inside that I'll define the path and the file name. So my path is, this tspark ben. Okay. So yeah, this is my path, and the name of my file is, just copy it, and the name of the file is fortune 5002017. Alright. So since I have defined my path, so my next step would be to add the file. So sc.add file. From where? From this path which I have already mentioned above. Now let's hit enter. Oh, what's the error? Okay. So yeah, it got executed. Fine. Now let's check for its root directory. So let's add another. Let's check for its root directory. Spark files dot get root directory. Define it. Let's see. So there's my root directory. Alright. So moving on ahead, in PySpark fundamentals we have RDDs. Well, there's a very important concept that you have to learn. Alright. It stands for Resilient Distributed Dataset and is a building block of every Spark application. So what is RDD? RDD stands for Resilient Distributed Dataset. Resilient as if the data in the memory is lost, it cannot be recovered. That is, it's fault tolerant behavior. Next is distributed. The data is chunked into partition and is stored in memory across the cluster. And finally, it's the dataset. That is, initial data can come from a file or it can be created using the program. Fine? Alright. So next we have types of operations in RDD. Well, we have two types of operation in RDD. One is transformation and other is action. Let's see about them in detail. So what is transformation in RDD? Well, these Spark RDD transformations are functions that take an RDD as an input and produces one or many RDDs as output. They do not change the input RDD, since I already told you that RDDs are immutable and hence you cannot change it. So what they do is they always produce one or more RDDs by applying the computation they represent. For example, map function, filter, reduce by key, etc. These transformations are lazy operation on an RDD in Apache Spark. It creates one or many new RDDs which executes when an action occurs. Hence, transformation creates a new dataset from an existing one. Certain transformations can be pipelined, which is an optimization method that Spark uses to improve the performance of computation. Next comes the action operations. An action in Spark returns the final result of RDD computations. It triggers the execution using lineage graph to load the data into original RDD. Thereby carry out all the intermediate transformation and return final result to the driver program or write it out to the file system. The lineage graph is dependency of all the parallel RDDs of RDD. Action are RDD operations that produce non-RDD values. They materialize a value in a Spark program. An action is one of the ways to send result from executors to the drivers. Few functions which are a part of it is like first, take, reduce, collect, and so on. Alright. So using transformation, you can create RDD from an existing one. But when you have to work with the actual dataset, at that point you have to use action. Remember, when the action occurs, it does not create new RDD like transformation. Thus, action are RDD operation that gives no RDD values. But in turn, what it does, it stores the value either to the driver or to external storage system, thereby bringing laziness of RDD into motion. Well, here is a summarizing image for you. As you can see, when you apply transformation operations like map, filter, sort by or anything, so what it does, it creates a new RDD. Whereas on the other hand, when you have to perform actions like using first, take, etc., then your existing RDD is saved as a file. Alright? So I think you guys might have a question in mind like when you guys should use RDD. Right? Well, here are some of the scenarios under which where RDD is most preferably used. First is the unstructured data. When your data is unstructured, for example, in case of a media stream or stream of text, you can use RDD. Second is the no schema. Well, this is the case where you don't care about imposing the schema, such as the columnar format or while processing or accessing data attributes by name or column. Fine. Next is the data manipulation. That is, you want to manipulate your data with functional programming construct that domain specific expressions. And finally, we have the low level transformation. That is, you want low level transformation in action and control your dataset. Alright, so these are the scenarios under which you can use RDDs. So next on the PySpark fundamental, we have data frame. So this was all about RDD. If you have any doubt, don't hesitate in adding them in the comment section below. It will be beneficial for you as well as for the other learners. Alright. So in the next PySpark fundamental, we have data frame. Data frame is a buzzword in the industry nowadays. People tend to use it with many popular languages used for data analysis like Python, Scala, and R. So why is that everyone using it so much? Well, data frame generally refers to a data structure which is tabular in nature. It represents rows, each of which consists of a number of observations. Rows can have a variety of data format which can be heterogeneous, whereas a column can have the same type of data type, that is homogeneous. Data frame usually contains some metadata in addition to the data, for example the column and the row name. Okay, we can say that Data frames are nothing but two-dimensional data structure similar to a SQL table or to a spreadsheet. Fine. I hope that data frame is clear to you guys. So moving on ahead, in the end we have the MLlib. MLlib is a machine learning API of Spark which in turn supports various machine learning algorithms. It is a machine learning library that is provided by Apache Spark to make the machine learning scalable and easy. It provides various tools for machine learning algorithm, featureization, pipelines, persistence, and utilities. Few machine learning algorithms which are a part of it are classification, regression, clustering, collaborative filtering, dimensionality reduction, and others. Alright. So as a part of featureization, they have feature extraction, transformation, and selection. In pipeline, they have a tool for constructing, evaluating, and tuning machine learning pipelines.
And this brings us to the end of the session. Do stay tuned to IntelliPad's YouTube channel for more such informative videos.